Alrighty. It should put me live on all the platforms. We gotta clean the desk off before we get started. The dog was sleeping under my desk. She was extremely cute. And then I started streaming, and as soon as I started moving around and setting things up, she left. She didn't want nothing. Didn't want none of it. This is OTT Skylon in the background, and as you can see, I've been busy. I've been a busy boy. I've been doing a lot of stuff. I'm trying to get a full speed run with the RC car, and I haven't been able to do that. Did I click done on the title? I think I did. I'm gonna hit refresh and see if my title's up. Otherwise it's gonna say the wrong thing. Chat events, beta, maybe later. Close it. I want you to ask me that again. I'm not ready to activate all of these things. Okay, yeah, I do have the right title. I've got a couple viewers. I have one viewer. Nice. Nice. All right, let's get YouTube chat up just in case. Click on that. Close that. And then I don't need the video. All I need is to pop out the chat. Pop out chat. Close this. I wish it had a consistent URL for the chat. Then I wouldn't have to do all this crazy setup stuff. Okay, get my head about me. Hey, Copper, what's going on? That vacuum tube video, I didn't get through all of it. That kid has an amazing setup. I love how all of his stuff, there's a YouTube video that Copper posted in the Discord, and it's awesome. This kid has all this glass blowing stuff. I mean, that's what science used to be, right? There are always these, like in universities, they have glass blowing shops right next to the chemistry lab, or at least wherever the chemistry lab was supposed to be. That's really cool. A lot of scientists were glass blowers. I'm not good at glass blowing. I don't know what it is. Tangible science and not the stuff you need to program computers to do because it's so tiny. Well, we got really good at etching. We got really good at etching. We got really genuinely very good at etching things. And we insmolinated everything. You can do a lot more nowadays, though. There's no denying the inexorable march of technology forward, but it was kind of cool when you got to blow glass all day. Try to get some of this stuff out of the way. The 3D printer I put back into working status, but I'm gonna have to crimp a cable on the end of this thing, and then we need to put the blower motor on the print bed, or sorry, on the printer itself, but I don't have a design for the actual blower area, so. Oh, and then we gotta get back to Dave's synthesizer. I built this little setup just so I could test radios. Radio's all working. Now I just have this block of wood with a bunch of stuff on it. I don't know what to do with this. This goes somewhere. Hiccuping. I have just been discombobulated with projects. I've got too much going on, and I need to circle back on a few things. I need to work on synthesizers and burn the subs. I think those two need to be the prominent projects here. I wanted to be able to do bridging on the printer, but being able to tangibly mess with things makes it easier to learn concepts, so that old tech should definitely be kept for at least educational stuff. Cheap enough for elementary schools to mess with. Teaching third graders how to do class art. Yeah, I mean, okay, I don't disagree with that. I constantly am saying, and it's one of my hotter takes, and maybe I need to do like a YouTube video on this, maybe it'll go viral, about how the 555 is obsolete and it's no longer useful or worth the time to learn. Part of it, though, could be argued that doing something with a 555 timer introduces you to basics that will be associated with future electronic endeavors that like you can't ignore certain principles, or you can figure out how capacitors interact with a circuit and get used to that and kind of grow your sea legs. But I don't know. I still think the 555 timer is completely obsolete. It's a useless chip. You would be better off using a microcontroller, and while that's overkill, you can't avoid overkill these days because microcontrollers have gotten so powerful. you're not going to be sizing a microcontroller's capabilities exactly to your project anymore, because now we're putting computers and everything. We're eventually going to be using stuff that's as powerful as a Raspberry Pi to blink an LED, and you can't avoid it because you have to be able to source the parts. And these less powerful platforms are not as available anymore. So there's always going to be microcontroller overkill going on. Embrace it, and in order to blink your LED, use a little microcontroller, and then you can learn how to program a microcontroller, and that can be a sort of a stepstone into more complicated projects and endeavors. We have to build one of these synthesizer units too with the ESP32. Again, it's like $1 for a microcontroller that's 32-bit these days. Crazy. Mad. It's mad. There's mad times. I am eepy today. I'm sleepy. Guess I didn't sleep well. Who knew that Loctite has to be stored in an air-permeable container? Learned so much about Loctite in the past couple days. Don't need Wi-Fi or Bluetooth, but that one ESP chip so many people use, it's like $1. It's crazy. It's a mad world. These little guys. The ESP8266 is kind of a neat little one too, because you can just throw code at it without wires or anything. What the heck? Oh, this like totally fell over. Okay, there we go. We were looking at my tool bin. Yeah, I printed a larger front bumper for this thing. Dun 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 dun. I can't do that. I can't nap. I don't know what it is with me. Maybe ADHD or something. Well, I know the meds probably won't let me sleep. Actually, from what I hear, the meds help you sleep better because you're not as absent-minded, I guess. I don't know, but if I take a nap, it just ruins my whole day. Like, I just feel out of time as an existing next to the normal timeline. I got a bunch of these guys. We use these to make synthesizers, some digital synthesizer modules. And I think I'm going to split my two synth boxes between analog and digital. I think one box will be analog and the other one will be digital. These things are pretty neat. Pretty neato. Neato gazebo. Of course, yet again, they don't spend enough time soldering the USB socket. I might be tempted to go in there with some of my own solder and just kind of, because you need to get that pad wet. You need to actually tin over that pad, because that pad is going to make those pins into virtual rivets. They'll be solder rivets, so they're not incredibly strong, but they will be much stronger than the bond of copper to FR4 circuit board substrate. That's the whole, VIAs also accomplish this well too. But I mean, if you really want to hold that pin in, it needs more solder than this. Better than hot glue. Anything is better than hot glue. Anything. Spit. This could probably power this whole project. Nah. But yeah, what I want to do today is, I always have to see if it's saliva, not salvia. Why are those two words so close together? We need to model the main board, and I probably need to rebuild the 3D model of the whole thing. I don't think we're going to do super direct representation of what's there, because I've done a couple mods like this thing here. This thing is pretty outdated. But I kind of want to start it over because the motor area is not quite representational of what's there. Not quite. And this is meant for a different circuit board to fit right there. One that would have had screws. That would have been nice. That was the AT Tiny 85 project, and it was pretty involved, and it didn't really work out, unfortunately. Didn't really work out. It was pretty cool, though. I would like to also, well, I don't know. I want to move that servo back a little bit because these things are colliding with the servo right here. And if we're redesigning this part, I can scooch the servo back just a little bit and that'll clearance. But it might also hit this, might hit the circuit board. So we've got to make that circuit board first, and then we have to start kind of repiecing this whole thing together so that it's a cleaner setup. Oh, that's in the back position. It should be in the forward position. Huh. One row of dots closer. Wave generators for synth setup using retro console sound clips. I mean, the modules exist. Yeah, you linked one in chat, in Discord. There's another one. There's one from Mutable Instruments that supposedly does 8-bit sounds as well. I was thinking about getting the circuit board for that and building it up. You have too many expensive hobbies. You need a cheap hobby. you need to like learn how to whittle stuff. Always great 3D models. These are not great. They're in a state. They need some work. So I was having a lot of issues with Twitch playback. I don't know if anybody's tried to watch a VOD, if it's just me, but Twitch seemed to not be able to load enough video data to prevent the time from the playback time from catching up and then like pausing the whole video. And then while it's paused, it thinks it's still going, so then it loads further up and you miss a little bit. It was unwatchable. Ran out of wood for whittling and I haven't had the time to pay $5 to go chop down a tree to turn into lumber for the projects. Then why are you So I decided to look at modular synthesizers, night vision, high-end audio equipment. Close the browser. Close the browser. It's all too expensive. The way that I'm getting into the modular synthesizers is through my skills at soldering and the ability to just purchase a circuit board. You just purchase the circuit board and then build it up from there. But it still cost me quite a bit of money. I mean, the money from subscribers basically went directly into that, and now I have to cut back. I have to stop buying stuff for a little bit. There's a lot of people out there that pressure me to do their project, do this thing that I'm doing, do the thing I'm doing, get the parts that I'm getting, do the thing I'm doing, and it's like, nope, not doing that anymore. Should get tested for ADHD. Yeah, I think the plastics in our brain have caused most people to have it. My goal for today, and we'll see if we can even begin to achieve that, is to have a cleaner model of the RC car and at least some ability to mount all of the boards in one place. One needs an RC car that's more expensive than their personal vehicle. That's 1/10 scale stuff. The 1/10 scale stuff that I was looking at. Because again, I got an all-wheel drive 1/10 scale RC car from a free cycle thing. My buddy shows up at my door like, hey, you want this? And I'm like, all right. And he took my welder in exchange, just because the welder was taking up too much space, and I don't have room for a welder. I just don't have space for it. Plus, I don't have the. Oh, did I give him the gas bottles? No, I think we turned in the gas bottles or something. We don't have them anymore. But yeah, they were taking up too much room in the garage. I had to get rid of it. And as a result, I got all of those crazy, like DIN rail stuff and a 1/10 scale all-wheel drive RC car. But I looked up some of the prices for that stuff because I was like, I want to put like a good 3-phase motor in it, and it's way too expensive. It is, Jesus, those, they're not pulling punches with the cost of these things. It's crazy. I have an RC car, still needs to do everything because the last person I let mess with the wiring fried everything. Yeah, that's the, well, I'm going a little psycho with the electronics here. Usually you would just throw your radio receiver on here and, you know, like it'd basically be like this, my weird test board. You have this thing just stuck to the top, and then you have your motor with a plug on the end, and then you have your controller with more plugs, and if anything goes wrong, you can pick it all apart and put it all back together easily. I didn't do that. I'm directly soldering wires down, and I would like to get all of these electronics in some kind of a mount so that I don't, because this thing, when this thing rolls over, it is violent. I need like a bar to protect this spring. When this thing rolls over, it's like a big deal. It goes pretty psycho. It is fast as all frig, though. I've been trying to get a top speed, and in doing so, I actually bent some of the previous rims. These grip much better at high speed. My guess is that the little nubbins keep this thing from sliding back and forth as much. $300 for a motor. Oh, that's 1/16th, yeah. 1/24th, this is like a $10, $20 motor. It was less than that. I think it was 10-ish. And it is the fastest thing that I've ever experienced in remote control. I don't do airplanes, or I don't do quadcopters anymore. Those are a little bit too much. I like racing around on the ground. I always wanted to really get into RC cars. The money needed for that hobby is a little bit much for my wallet. Yeah, that's the only problem. This is death by 1,000 individual $20 cuts. The metal parts, like you can buy the metal parts kit for $20. The whole model, I think, was 60 or 70. I think 60. But then each like carbon fiber upgrade was like another, not really $20, but close. And then the radio receiver, $20, the blah, 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 blah. Every individual thing has been $20 of this thing. And I've trickled it down over months by going, oh, it's not that much, and just ordering it. But if I were to do it all at once, that would be an amazing pain in the ass. Clocked the RC car at 80 miles an hour. I wish that this thing had like something resembling telemetry, because I would love to know what speed I was actually operating at with it, because I know it is not stable at full speed. At full speed, when I really bury the throttle, it like any disturbance would set this thing going crazy. The gyroscope, being able to set the gyroscope to just a little tiny bit of assistance was amazing. It's so stable now at speed. Oh, that's convenient. That would be nice to have a little radar gun. I mean, I could also set up like a gate, or I could set up, I don't know, maybe a ultrasonic bounce. That could work. I know I have one of those. I don't know if it would be able to go up to the speeds that I want it to. This thing could see how fast the wall is approaching. Excuse me. Does the gyro correct for steering? Yeah, it does, unless you set it to the other direction, in which case it actively sabotages your steering. Why you would want that? I guess a drift car. I guess if you're drifting, you want it to like break your grip and start sliding around. And then you can also turn it off from the radio. That was the whole purpose of us flashing the controller, is so that I could get that feature. But the problem is, it's not exactly that feature. And the last time this thing was updated was 2012, but what the software allows me to do is set the channel 3 from -100, which is off, to -50. And then I can use this control to temporarily change it to a different setting. But -50 is actually enough for the high speed runs that I wanted to get to. So the car was lifted off the ground while power is applied to the wheels. The tires just expand trying to come up. That's exactly what this one does. I glued the tires down, but then I had some kind of a horrible accident, and I think I bent the rims. How can I test that? I would need to like bring an axle back to life, and I don't think I have the bearings for it. I don't have axle bearings, spindle bearings. Yeah, I don't have spindle bearings. I have every other bearing imaginable, just not the ones that I need. Actually, where is one of the plastic axles? Maybe I can set up an axle just to spin. Show you guys how horrible the wheel is. There's one axle in here. Back that axle up. Hold on, I need to actually like put it in something I can spin. All that hair, that dog hair on everything. God. Oh, I see. That's actually larger than the thing that it's clamping to. That's not good. Yeah, that won't work. That will work. Okay, what else do I have? Just a small collection of bearings here. I don't think these will do. Yeah, well, that holds, but it's also more narrow than the thing that's spinning. Of course, none of these will work because they require much larger bearings. I just want to show how off the wheels are after the one crash. Here, wait, I have an idea. Forceps. Yeah, see that wobble? Well, that actually might just be because it's loose in here. Let's check the others. That one's pretty good. Not a lot of wobble there. That's a good bearing, too. There's a little bit, though. Oops. It could also be my setup is a little janky, so. That one's still good. I think I need to like tighten it up. I don't want to put a bolt on there because that's too permanent. Looked okay. Hey, how's it going, Blue? How you been? Yeah, this one's pretty damaged. Look at that. That's unacceptable. Why is it doing that? We had to get a generator because we're kind of out in the woods, and we got a lot of bad blackouts here. And ever since we got a generator, I think something triggered in Pico Energy's monitoring where they said, oh, they got a generator? Okay, well, they'll never have a power outage again. It's been like 2 years since we've had a power outage. They did a bunch of cutting back of lines from trees, and that's really annoying because we spent a genuine large chunk of money on that generator. I guess it's just peace of mind at this point. But then, because of the way the generator turns on, and because of all the power outages we had previous, I set up every computer here to have a UPS on it. So I've got a CyberPower on my desktop, and then over here we have TripLight, a rack-mounted one in the streaming rack, and then also one of those cheap like $60 ones that just does like a couple minutes, and that's on the internet, where the internet comes into the building. That way, when the generators flip everything on a moment or two after the power goes out, everything will still be up. Better to have it and not need it. I don't know about that in this scenario. I understand that completely, but also at the same time, it's annoying to have gone through all of that and never having it justify itself. I think this one is actually damaged. I mean, this wheel is not... That's not cool. It looks totally fine. I wonder if I could, like, tweak it back and make it good again. I like these wheels. I liked these wheels, but now they're bent. And if I use the 3D printed wheels, I suppose they would explode on a crash, which is better than denting, because then you know it's dead. And I can 3D print a replacement. Apparently they're banned in competition. I don't know why. They banned 3D printed wheels. See if we can find a 3D model of the motor. It's a more complicated model. Oh no, I don't know which YouTube chat is the current one. Okay, well, maybe I'll leave both of them up. Yeah, I don't know. Too light? Too fragile? That seems unlikely. Especially with some of the filaments they got now. They got some crazy filaments these days. Crazy go nuts. All right, let's see. We want to do GrabCAD. GrabCAD. Community Library. WL Toys. It's not a WL motor, though. The one that I want to use. Everything is the 5950B or whatever. What is that motor called? What is that motor called? What are you called? What are you? Wait, I have another one in one of these bins. Where's the bin with the motor in it? Oh, you know what? I put it down here. Did I put it down here? What did I put where? What did I do? Is it all the way down? No, it shouldn't be. It's too deep. This is where all my wheels are too. I got these fancy pants. These would be if I wanted to drift though, because they're plastic wheels. It's not in this one. So where then shall it be? Just double check and make sure that I didn't actually put it down here. What's up, Brink GG? How you doing? How are you, my most loyal fan? All right, let's see. I am looking for the other motor. I don't know what I did with. I had it in one of the bins here, but then I moved it somewhere else. Did I put it? Maybe I put it in the tray, the RC car stuff tray. Oh yeah, that's right, because I was observing what I would have to modify on the Mario Kart home circuit in order to put that motor in there. Where'd that go? The motor's in this bin somewhere. After seeing the incredible speed that I'm able to achieve with the 1/24th scale car, I'm starting to think like, hey, what if I put that in the Mario Kart home circuit and made it go 11 million miles an hour? That would be funny. Where the oh, there it is. Okay. Yeah, so the part that I would have to modify is, well, two things. One of them is this back piece. I would need to be able to 3D print that, which is not easy, but then remodel the interior part of it to house this motor. And then I would use this axle. This axle, where did it go? Where's my actual, is it safe? There it is. This axle, which is not long enough to span the entire thing, I would have to make modified hubs to mount it to the back wheels, and I don't know how that would hold on. So I'd probably need to just build an entire wheel hub that went into this, and this would need to be really well supported because it would be this big moment arm. Pissed at you UPSs, but in love with my 3D printer. Oh, do you have your 3D printer on a UPS? We just had Baloo was asking me about the power supply setup in here. Oh, that's the wrong, wait a minute, that's the wrong one. Where are we? We're somewhere else. There we go. Ooh, they got theremin on this song. Wait, I think I've said that before. So what is this motor that I have? My brain is scrambled today. Rocket RC 2500 kilovolt. Or no, it's not kilovolt, it's just kV. That's a measure of how much the motor turns at a volt, I think. So I don't think Rocket RC is going to get us anything, but we could try. Damn it, wrong one again. There you go. So we're going to find a lot of 1/10 stuff in here. These are expensive. Pushrod suspension for an RC car. That's kind of cool. Why the holes? And there are the little... Yeah, that's clever. Ha! That's pretty cool. Two different situations. 3D printed an ATX to SFX PSU bracket so I could put my big-ass server motherboard in a Rosewill rack case. The Rosewill cases are pretty nice. I like those. I think I have... Is that one Rosewill? I don't know who makes the one that I ended up using, but it's got all my hard drives and stuff in it, and they've all... Each hard drive has at least half of a fan to itself. Yeah, speed holes. Maybe it's just for foam tires. That's better. I don't know. UPS decided to kick the can with no warning. Oh, that sucks. What is that steering? I guess so. That's a weird way of doing rack and pinion. I guess that's just like an outrunner as a servo. I don't know what the hell. Hold on. Steering servo. Is that like a new style? Because I have a little motor like this. It's just kind of funny that they would be using it as something for steering. Maybe it's like a senior design project or something. People be getting crazy with their ability to 3D model stuff these days. Everything's just like a normal servo. What is that? Like a hydraulic steering servo. Everybody's just doing a normal servo, including me. Belt drives the loads not directly on the servo motor. But it's one of those, it's like a helicopter servo. Going over to another helicopter servo? What's that all about? Because that's not, this is just simply steering. Going to the back of the spindle. And the push rod's going up here and getting redirected to the balance bar and the thrust or whatever. It's some kind of a flex. They're flexing on us by using a weird servo there. What's the front one look like? Oh, that's the side of the thing. Interesting. There are not a lot of results, huh? 3-phase motor. The problem is we're going to get everything under the sun, and I don't know exactly what to look for here. How this website needs help. It needs help. I think it expects to be full screen, and then those are the only results that I get for 3-phase motor. RC motor. Bring that back to size. RC motor. And there's probably going to be 10 billion results. We might just have to represent the motor with just like a can, because I'm not going to get too complicated with the modeling. I'm going to burp. I burped. Model rocket test stand. Good Lord. The stuff that we can, oh, well, there's rocket. The stuff that we can accomplish with technology these days, like, pretty much overshadows what, like, military testing used to be. People out here with accelerometers and load cells and 3D printed stuff getting by, making all this technology. Wait, was that goggles? What was that? Oh, it's gone for, wait, what is it? Okay, never mind. It looked like a pair of goggles. Weird. That first rocket RC was, I don't know, I don't know if that's exactly the right thing. I don't think it is. If it's close, microscale RC tank, needed a model of the motors, so here it is. Dimensions are taken off of their website. So we can compare this to, it's probably the larger size. So just looking at it, I think it's the larger size. We may have to just make a representative thing for the motor, which won't look good in my detailed model, my super detailed model. The system where the chassis hangs from the suspension system is neat. Mostly only seen it on off-road skateboards. I don't know what you mean. I don't know if was I looking at something like that? That's intriguing. The motherboard is big. I had a weird repin that I had to do where for some reason they thought that the motherboard, the power, the ATX power connection should still be on the big Molex with all the same representative pins that lock into place, right? Not even like a different Molex with different, you know, Ds and boxes so it doesn't fit. No, it fit directly in, but it had all the 12 volts on one side and all the ground on the other. It was ridiculous. I had to make a Molex pulling tool and then redo all the pins one for one. It was maddening. Land Rover Defender D90. Neat. See, like, the problem is the keyword is, it should technically be like 1/24th, but people do other stuff with these motors. It's not just for 1/24th scale. So it could just, you know, it could have been listed as just about anything. Let's look it up. Rocket RC 1/24. I could add motor. We get fair RC. I like how they don't picture the controller at scale. This looks a lot like, all right, this does actually look a lot like the model, but the motor that I have has 4 cuts in the front. So I think this is a much larger 3500 kV. I put 1/24th. Oh yeah, it's right there. Did they update their design to have more cooling? They might have. I don't know, having this many cuts, like, where are the mounts? They're, oh, I see, they're on the little pylons. And then this is a circuit board, and on the other one they show it as not a circuit. Well, I guess it does have a radius on it. So 3 screws in the back. Those are chewed up because it didn't quite. I mean, this does fit where those other motors fit, but yeah, this doesn't have 3. Oh, this has a sensor. Oh, how much is this? Oh, as I die yet again from a price tag. I would assume that the sensored motors are way nicer at low speeds. This one does have the plug for the sensor on the back. I don't want that. I don't have a sensor. We flew so close to greatness, but we missed. And we ended up among the stars without any contact, physical contact, for thousands and thousands of years. Alone and forgotten. So surpass hobby rocket. So if I do rocket motor is not gonna give me the right results here. Oh, maybe it is partially, but a rocket motor is a completely different animal from our little RC motors. I could mod their model, yeah. Maybe that's the way to go. We can just cut the things we don't want. What is the specific model that I have? Hold on a second. I got to pull up something over here on the monitor that doesn't have an OBS scene. Let's see exactly what I ordered. Oh, it's in pick up where you left off, and it has the exact page. It's pretty nice. We so you Rocket Mini Z 9500 kilovolt, two pole. I don't know about that. Brushless, 1/28, blah 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 blah. High torque metal. This thing is a beast of a motor. See, like this would be easy enough for us to just model. I think I could just take that as like a circular cutout, and I don't know. So this one doesn't have a part number. Yeah, all right. So, we can either make the model or yeah, I mean, you could do that. You could do cylinder with the thing coming out. It's a slightly more complicated, but not by a ton. Yeah, this is not like it's 1/8 scale. Okay, so this is a big motor. But then again, I could also just take this model and cut out the sensor area, just so that we have an approximation of the size of the motor. Because we're not going to be designing tightly to the motor. The motor needs air. It's funny, rocket motor is not coming up with the results that should also include that. I mean, maybe it's just the resizing the window. Yeah, there's more pages. It just got cut off. Not a lot of RC stuff going on here. Wait a minute. How did that come up with a search from rocket motor? Huh. Why is it coming up with that? Ugh. Stupid website. They don't let you resize it to a more narrow thing, and I need a more narrow thing because I have all these boxes up at the same time. Rotary rocket engine. Rotary rocket engine? Hold on a minute. What do you... Huh? Give me a cutaway. Oh. So it's just like blasting in a circle? Oh, that's weird. That other rotating rocket nozzle was kind of insane. The one where it was just like two explosion sites that were rotating in a chamber, and that apparently makes extremely efficient rocket motor. But you got to time it just right. Well, that's fascinating. If you really absolutely have to spin something to the absolute limits of its ability to hold together, rotary rocket engine should be your consideration. 1/24 motor. That's a big, what is it, the geared motors for like robots. Robos. I can see you back there, but I can't click it. It's every now and again somebody will have like a really tall image and it just blows up this site. Why do you allow this? Why do you allow this? Ah, not quite. Not my tempo. Not quite my tempo. Not my people. Stepper motor. Any approximations? I don't know how popular 1/24th RC cars are. I kind of fell onto the scale because of Mario Kart Home Circuit, and I thought it was really fun because you can race them around indoors. Although I have been taking mine outdoors. It's 1/10 scale is much better for outdoors because if you strike a pebble in the road, it doesn't break your car. Mine does. Mine explodes whenever it hits just like the littlest piece of gravel. It'll start flipping out and flipping all over the place. So it's more for indoor carpet racing. But again, I don't know how popular they are. 1/10 is really where everybody is. This has been a little bit more of an experiment in Fusion 360 and learning how to make stuff in CAD. So we're going to be kind of taking a dive into Fusion. What's up, Mahalo? Rotary engines are neat, but also seem way more complex. Boost in, main sails out, right? Main apex seals. That's not main seals. Boost in, apex seals out. They require maintenance. They are really good for the size of the motor, though. Rotary engines. And they're just a different technology that hasn't had as much time in the sun as your normal internal combustion setup. I think if you had more, like if rotary engines were more universal, there would be more engineering behind them. All that engine technology within like what 10 months in the 1800s, everybody came up with every single kind of engine possible. It's insane the amount of technology that mankind just decided on. They had parallel ideas. Like the automobile was invented within, like in the United States, not in the United States, wherever they invented the automobiles, there in Japan, like simultaneously came up with the idea. It's crazy. We're looking for a 1/24th scale 3-phase motor while we wait for the stream to start. While we wait for the streamer to start the stream. I don't know when they're going to do that. They're always weird about it. A new revolution to come with 3D additive manufacturing. It's mostly been like swapping materials for materials, right? Like you can have plastic engines now if they do the sleeving and the cooling right. Oh, that was the end of the album, wasn't it? Oh no, there's still a little bit to go. See, this is pretty much 1/24th slot car motor. That's kind of the size that we're dealing with, but we have a slightly different motor in there. I'm just trying to find it so that I have everything I need to get to the actual designing part of the stream. It was either going to be this or 3D printers today. And Burn the Subs is, of course, lurking on the horizon. We will get back to that. Everybody, you know, my boy, the Y-Wing, always gets a bad rap. People hate the Y-Wing. I don't know why. I love it. It's like my favorite Star Wars ship. My favorite, but everybody's like, HD Y-Wing sucks. At least they were like that in grade school. We've all grown up now and have become more tribal about it. Pneumatic engines? Pneumatic and alcohol engines. Yeah, well, the thing about 3D printing, yeah, not a lot of people have, you know, the sintered metal 3D printers available to them, and 3D prints are low temperature, so you're not really going to be seeing a lot in that realm. The people who are building those, I mean, you know, CNC has become much more prevalent though. So those model kits where you build an air pressure replica motor, those are so cool, but they're like $500. So I'm never going to do one for a stream. I can't afford $500 material for stream to keep for one stream or two. I could probably stretch that out over a couple streams, but it's still, I don't get that much money from streaming. I really don't. I get most of my money from illegal drugs. I have a big slingshot, and I just fling a package over the border every now and then they deposit money into my account. That's just how, you know, we do it. We do a big slingshot. It's huge. It's a trebuchet, actually. None of these are, like, quite what I'm looking for. There's some fascinating stuff. Like, whatever the hell this is. Cylinder blade. People just like spirals. Clear resin boxer 6 with certain components printed in pink nylon. Smarter Every Day is working with, or at least did a video recently with one of the guys that's doing clear engine stuff, and he's got some pretty fascinating setups. That was just being able to get a like slow motion of an internal combustion engine doing its thing was pretty cool. What I'm doing is I'm doing a deep dive and looking for a motor that resembles what I have. Inrunner. This looks like it's very close, but I guess we'll have to make our own model. So that's just an inevitability. That probably means that I should start. What time is it? The good old CIA plan for making money. Yeah, I just sell long guns to people without any paperwork. I mean, like, it's just a matter of finding the search terms, right? Oh, good. The button to get to the next page is completely covered. Fuck you, Longship. You Viking piece of shit. You blocked my ability to click on the next page. God, this website. Why is there always a big thing right here where it's going to block the... Do that. Maybe that'll... There we go. So I had to go into the narrow mode in order to get it to... What the heck? I don't think we're going to find it. I think there's just not enough... They're not popular enough, and there's just not enough unique keywords to the device. It was a month ago? Yeah. That's right. That one was all reed switches. That one wasn't actually functioning. I remember for a little while everybody was going nuts about a cylinder mod where you would machine a little trough in the cylinder, and that would cause more turbulence in the airflow and cause more complete combustion. But like, there were some incredibly crazy claims around it, and it turns out that modern manufacturers are doing something similar to that in causing just a little bit of turbulence to allow for better mixing of combustibles. And so that mod, while it works really great for like a old like 1980s Indian dirt bike, it doesn't work for modern engines. But people were going psycho about it, and it was like it was a new claim. This new technology that no one's discovered before. Well, no, you're working on old-ass two-stroke engines. All right, so we didn't find it. We're going to have to model the motor. Darn. Because, yeah, this is close. This is a censored motor. I would love to have something like this, but we saw the cost. It's like a $90 motor system, so that ain't happening. Yeah, there it is. $86.98. What is the 98 cents doing here? Why is that so universal? Can't we just do whole numbers? Like, we're not dumb. But that requires this whole thing. Mini 28 Pro with a programmer. Ugh. $90. Can you believe? Yeah. What was the original price? Listen, we all know that, Brink. We all know that it sounds cheaper, but there's not much else to that. I mean, like, everyone does that. Just stop. Just give me the price of the real thing. This 99 crap. I don't think I've ever had a decision made or broken by that last little bit of expenditure. Where did the window go? Let's keep my windows tight. Let's check to see if anybody says anything on YouTube. I think the people who are subbed to me have realized that it's not worth it. I've reached my peak subs already, even though I'm daily uploading. $320 seems cheaper to the brain than $150. Psychology was a mistake. We should never have studied it. I don't know. Is this not loading over here? Are we not getting chat up there? I might need to... Well, my pop-out is here. That might just refresh it. I just have to click on it in order to make it do stuff. Then hopefully the social stream ninja will pick up on it. This is a tough camera angle. I moved this camera because Willow doesn't really visit me anymore. She likes to spend her time outside of the lab, and I forgot where I pointed the camera. So this is incredibly awkward. You guys are not supposed to see the shot from this angle. I need to do my recycling. There's a little bit of a pile-up. Not all of that is trash. What are we looking at here? Circles, inside circles. Everything is given kind of a soft edge. We have a plate on the back that I guess we'll just put as part of the regular model. We got other circles and circles inside of that. I don't know how everybody's out here modeling the windings. I don't know how they do that. I mean, we could modify that other model. We could see what that other model has, because I think they've, aside from the holes being a little cheaper, I think they probably have the same dimensions. Let me sign in on the website here. What password did I use for this site? Hunter2? I gotta click download a second time. All right, there we go. So we're getting these files. Maybe we could just modify them and that'll be that. All right, let's get started. Get start soon out of there, get the music out. You guys can't hear it in the VODs anyway. I know that most of you aren't here yet. If you're watching this on a VOD, it is oddly quiet because I'm playing music in the background, just kind of psych myself up into streaming. I think I almost canceled today. I did. I'm just not feeling great. Mostly it's just sleep related, and I'm going to be fixing that. But it's also just a VOD people aren't allowed to enjoy stream music. Yeah, they don't get it, and YouTube doesn't get it either. Only on Twitch is the music. So join us on Twitch. Anyway, it is a dumpy, rainy day here. We're supposed to get something like 3 to 4 inches of rain in the next 24 hours. You can see it's all dark in the window. So why don't we just have like a chill day and work on some RC car stuff? It turns out the RC car stuff and the 3D modeling stuff are some of the most popular stuff that I stuff. I've been working a couple burners simultaneously in terms of RC car stuff. The original idea was to take the Mario Kart home circuit and modify it in order to super hyper cheat. And we lost track of that. I kind of lost sight of that entire project and where that was going. The way the Mario Kart home circuit works is it was originally a WL Toys 989, I think, kit, which is an all-wheel drive, fully suspended little RC car pan, 1/24th scale RC car pan, and then they put just a big plate on it, a Raspberry Pi Zero W, and a camera, and they made Mario Kart home circuit out of that. We were going to modify it to have like a better motor and maybe some other advantages like having a differential and suspension. But I kind of lost sight of that. We didn't work on it for a long time. And so what I ended up doing is taking the 1/24th scale RC car and actually giving it a real motor, a decent speed controller, a gyroscope, a 2-cell battery, and an extremely small and light radio receiver, which is right now sitting next to the motor, with the intention of packing it in and making it really neat and tidy. In order to keep the project going and keep it fresh in my mind, I decided just to get the wiring done. Just do it, right? Just do the thing, make it work. And so we ran into the fact that I needed to reprogram the radio receiver in order to make the gyro adjustable on its full scale, because when this thing gets going, it really, really gets going. This thing is extremely fast, like notably fast. It's a lot faster than any other RC car that I've ever had. I have been racing it around on the pavement outside, and any small stone will send this thing basically into a tumbling orbit. But at full speed, this thing gets away from me quick. And then with just a little bit slowing down, it's able to handle turns really nicely. I have not been able to get a video of it going full speed because every time I try to do a full speed run, it explodes. Everything breaks on this thing. This thing is constantly breaking, which is good because I like fixing it. That's fun. But like these little struts right here, these little 3D printed parts are typically what breaks on this thing, because when you get into an accident, a lot of the force is going into parts like this. And if it's a metal part, it's not really going to give. It's going to bend or break everything around it. So these actually act as sort of a fuse for when I get into an accident with this thing. These little pawls. I need to pack away this bundle of electronics. I want this to actually have like a home where I can get to it, get to the buttons, but also where I can mess around with, I want them all to be in a home so that if it gets into an accident, it doesn't rip a component out. Usually what you do is you would have all of this stuff plug in individually with plugs, and then you have spares in your kit so that if something breaks, you can plug in a new one. How expensive are custom RC cars to get into a hobby, as your opinion? Listen, we started this as kind of an exercise in modifying a thing. The WL Toys kit, hold on, let's take a look here. WL989, $70, or just some nice underwear. 70-ish, and that comes with a really terrible remote, and it's a 2-cell, and it's not very fast, and it uses a different type of motor, and you can just get started. You can just build this. Well, you don't even build it. It actually just comes built, which is really unsatisfying. What do you call it? The Mini Zs are extremely expensive. They're a lot nicer, but they're much more expensive. It's $180. It's incredible. I went with the WL Toys kit because it was cheap. I actually started with a much cheaper kit, though, a much cheaper 1/24th scale RC car. So, I mean, one of the problems that I have with this is that, like, if you want to cheap out and have to build it yourself, the kits that you build yourself are extremely expensive because they are like professional kits. If you want to start with something dinky and cheap, it is incredibly dinky and cheap. If you do something like the WL Toys kit, it's less dinky, but I have been upgrading part by part, and each upgrade is like $20, every single one. So if you do it all at once and you think you're going to be getting into this and like racing around the car, it's expensive. It can really be expensive. I've been kind of trickle feeding this since 2003. No, since 2020. It was sort of my pandemic. I was like, I can make an RC car that I can drift around during the pandemic and have fun indoors. But it's another bottomless hole. Pretty much. I mean, that's RC cars. It's computers, RC cars, real cars, guns. Any of these boy toy hobbies are going to really set you back quite a bit. Now, having the 3D printer does help a little bit. I was able to print some parts, but the 3D printed parts are nowhere near strong enough. For instance, you know, on the axles, these things will break immediately at the speeds that this thing goes. Yeah, if it's about learning instead of performance, it can be very cheap. Synthesizers, god damn it. I was able to pivot into synthesizers just simply for the soldering skill and the ability to buy circuit boards and build them up. Although my parts collection had to go through a little bit of growing pains in order to get there. There were a couple death by tiny little cuts, death by little purchases that had to occur. I still haven't lost sight of this one though. I do want to make this axle work with the Mario Kart home circuit and then have this on a really high kilovolt motor that'll make it go super duper fast, because I think that would be very funny. A sheet of aluminum, a drill, and a fret saw makes lots of really cheap parts. That's true. That is true. I've just been using threaded rod for all the rods on this thing, but you know, you can find models of the pans and stuff like that. You can even, with the 3D printer, you can find a lot of this scale RC stuff on Thingiverse. There's and larger scale too. There's a lot of RC stuff on Thingiverse, and that way you'll always have spare parts. Yeah. Actually, Copper, a lot of people have been making those chips again because they got the rights for it. A lot of those synthesizer ASICs that people made, which is a problem because they then died and took the rights with them. So what do I want to do today? Well, first off, I want to fix my 3D model. My 3D model is missing a couple components, and I don't necessarily want to fully model the replacement here, but I do want to get this motor because I want to design something that'll hold all of these circuit boards. Now I have a lot of it modeled. I have the radio modeled and I have the gyro modeled, but since we're no longer using my own circuit board for the motor control, I need to get a 3D model of this motor controller. So the goal, I guess we're going to start with the motor and then we're going to move on to this area, but then we also need to fix the 3D model. It's got a lot of stuff in it that shouldn't be there, so I think what I need to do is basically make a new frame model from scratch. Not really from scratch. I have all the parts in Fusion 360, so we can just basically piece together another physical representation of everything that's here, and maybe I can incorporate these guys in the... because I changed this the other day. I actually put the tie rod ends into the holes that are meant to mount the body, and what that does is it gives it a much flatter... okay, this used to connect to a piece right here, and that would cause the wheel to turn when it bumped. It was bump steering. So now it doesn't do that. Although I think I probably should have the shorter tie rod end on the thing, but still, it doesn't bump steer anymore. That was the whole point of that modification. Seems like it's got a lot more unsprung weight, but okay, so going to Fusion 360. Let's take a look at that other motor model and see if we can turn it into the motor that we have, because it's a much nicer motor. It's a much nicer motor right now. Oh wait, no, we're not doing that. I'm going over here and motors. So let's add a motor to the motors directory. Upload. And we'll go here. It has been a lot of fun working on it, but it's totally like, we're getting a lot of rain right now. And this RC car is so low to the ground that it is not operating in the rain. Some you can get away with operating them in the rain, but this one is definitely a no-go on that front. Do we do the step file or do we do F3D? I think the step files are usually cleaner, but that one's Autodesk Fusion 360. I guess we do the F3D. I need to upload a lot of the stuff that I've done on stream. I need to put that up on like GitHub or something, so you guys have access to it. Upload progress goes like that, and then it lags for a while. Oh no, this is much faster. They must have done something. I thought in the past, I think Fusion 360 was intentionally slowing down those uploads. Okay, so they made it as just one big part. This is a very shiny model. Look at how shiny that is. And this isn't quite what we have on the front, but maybe the hole spacing is similar. so let's just get a diameter of this thing and compare it to what we actually have. Like that, and the diameter is 15 millimeters. Double check that over here on our dimensions. Ah, 15 millimeters. Well, howdy do. What about the length? This is going to be different because it's a separate animal. So 25. No, I haven't done anything with Monster Stadium trucks. I pretty much found the WL Toys kit and just kind of went from there because of the Mario Kart Association. Oh, 24.9, 25. What? How does that work out? What about the distance to the solder lugs? Because they're the same. They're the exact same length. These two. Yeah, like that's 25, and we've got 25 on the clock there. Only ours has a piece that sticks out of the end a little further. So I may have to take it back from 25 and flatten it down. Let's see. Okay, distance to the circuit board that holds the that you solder to. Ah, slipped. 20.41. I know Shorty's doing some stuff with the monster trucks, I think. $18. Okay, so that moves back to, except for the fact that they already have the coils modeled in this, it would almost make more sense for me to just start over. Oh, we have all the steps here. Look at that. Hey, that's pretty handy. So I can actually remove the stuff that we don't need. Yeah, so the pins are for feedback because this one has sensors in it. If you have a brushless linear DC motor, BLDC, is that linear? Is that the right word? With a BLDC, if you have sensors on it, you can know where the magnetic phases are, and you can have a much more advanced controller on it. And I believe that would enable you to have the motor work at much lower speeds. It also makes it incredibly efficient. You don't need, in order to run a three-phase motor, you don't need the sensors necessarily. And so what I got was the cheaper one that doesn't have the plug for the sensors. And so this 3D model is not exactly what we have, but I think we can modify some of the steps in it. Boy, howdy, are there a lot of steps, and they're hard for me to see because the face cam is like right there. The face cam comes up a little high on the a little high on the monitor. I don't quite have you guys under it. You get a lot more low-end torque. That would be super advantageous to me because I like driving at lower speeds with tiny little RC cars. However, the one that I have is incredibly powerful. I think what I can do is undo some of this stuff and then make a sketch that will then extrude into that and make the back of the motor. This one looks like a 540 motor. 540 is the diameter or smaller. 540 what? Because this is 15 millimeters. Here, it's this. This is what we have to model. It's this little tiny guy. You can do this here. Well, I don't have that light isn't going to be on, so I guess the microscope isn't going to show it. Yeah, there are. They're the censored ESCs, but they're more expensive. Much more expensive. I'm using DOS Micro, which is, I think, a Chinese company, but they have very good, they make things very good and small, and their things are not expensive. But when you get into the ones with sensors that can properly utilize the sensors, you're in like a different tier. Everything is much more expensive. Yeah, it's absolutely minuscule. I guess I can rewind the timeline and undo some of the stuff, but I'm trying to see what's going on here. Why is origin visible? I don't need that. All right, let's see here. Like, what Fusion allows me to do is I can actually click on the stuff and it'll show me the step that actually generated it. Yeah, see, like that. Oh, wow. Wait, all the pins are made over here? So he used a revolve, and then a chamfer, and then a sketch for just the pins. Wow. Interesting. We don't need none of that. Where's this generated? Or is that just like, is that going to be an extrusion? What is that? Here. Because I don't think we have that either. We can just boip. Boip, boip, boip. It's still there. Be gone. That gone. This gone. Now we're getting somewhere. This needs to be moved. That is created a million years ago. Where is this thing? Yeah, we don't need that sketch either. That's flattening that piece. Bonk. Which we are we circular the whole way around? Oh, there's a little bit of a flat spot behind it. Well, I'm not going to model that. I'm not going to model that little flat spot behind the pins. That seems kind of crazy. Unless I, excuse me. Unless, hold on, let me measure it and see what that extrusion size was. It's 2 millimeter. Maybe I can modify the extrusion. Wrong end. Hold on. Hold. We're starting from, okay, so let's start from here and go 2. Now, did that cut anything that it shouldn't have? Well, there's a little Z fighting going on. A little bit of Z fighting. And does that have, yeah, it, well, actually, I don't think it's as deep as they say here. Somehow this, though, doesn't, it goes all the way out to the ends. Like, there's no, there's, How does that work? Wait a minute. Let me get some measurements here. It's hard to see anything that I'm doing right now. Everything is so small. Eight millimeter from end to end. Let's measure this. I think maybe it's less, you know what? I think it's just less deep. So let me take this distance from here to here. That is 0.59. And so I go back to this sketch, and instead of, what the heck? It's just completely floating in space. I feel bamboozled. 0.59. Wait, why is, huh? How does that work? Wait, what is going on here? Look at this. So, oh, because I chose this whole piece to extrude, that's why. And they're cutting it from here. I would assume that the distance from, I chose the wrong extrusion. Distance from here to probably the bottom of this thing, I'm gonna guess is 0.59. I can't really select it. It's that's gonna give me the wrong measurement. I'm gonna guess that the difference between those two is 0.95. So, but that cut in this one, that goes all the way to the edges of that board. It's not as narrow as this. This is their setup for the connector. So we don't, yeah, we shouldn't even need that sketch anymore. I'm just gonna finish the sketch and not affect anything. What we'll do, I'll just do a press pull on this and I'll lift it up 0.59. There, that's what we have. And this whole assembly needs to be moved down. I should probably also do that, whatever the width of this thing is. So what is that width? So we don't have Z fighting here. 1.5. So I guess I could just do extrude this, and I'll do, actually, we'll do this. We'll do a combine or cut. So keep the tool. We want to cut. Our target body is the main body, and our tool body is this piece. And so now that's cut in, and we don't have Z fighting anymore. We don't have two surfaces that are inside of one another trying to fight it out for honor and glory. And I'm actually going to delete the timeline after this point because we don't need any of that other timeline. So delete features after history marker. There we go. We're cleaning up. We're cleaning up the streets. We're cleaning it up. All right, so where are we placing this circuit board? Because right now, the distance to the circuit board is from here to here. And that's 18.5, whereas ours is at 20. So 18.5, so we have 1.5 millimeters to move. Is that right? Yeah, that's 1.5 millimeters off. So it's not the end of the world if we don't do it, but we probably just should. And then I'll have to make a sketch for the little nub that goes on the end. What if you want to go back now? I'll never want to go back. I'll never go back. I guess if I end up spending $100 on a motor system for an RC car that I barely ever use, I will regret my decisions and load up the other file. It is really cool though that you can get a censored motor in this size, and as much as like the what do you call that, the FOMO, all the FOMO running through my brain right now is making me really want to start looking up one of those censored motors, but it's really not necessary for this model. This model is fast. It's good at low speeds. It could be better at low speeds for sure. It gets a little choppy, but I can put in this motor, the spare motor, and that one will be even slower and more controllable. And I can change the gearing. But no, I'm not getting a censored motor. I'm not putting that much technology into this. If I lived next to an RC car track and I was racing this thing like every other day or every weekend, I would consider it, but it's simply just taking advantage of FOMO and technology. And I studied motors in college. I need it. No, I don't need it. I'm not going to do it. I'm going to look it up. Where's my browser? I can't take it anymore. Can this do censored? Does DOTS Micro have a speed controller that does electronic speed control? FlySky Nano 7 channel integrated 2 standalone bidirectional bidirectional ESC with brake 187, brushed ESC. ESC, this is the programmer for the craziness. Mini Z Evo main unit set compatible for blah 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 blah. The rabbit hole is slippery, straight to the bottom. You shut up. Yeah, I put an O drive in it. That's the size of the whole RC car. And I already gave my O drive to Twisted Sister. What is that hookup? This is the one that I have, the V3. We'll open that in another window. They're using SO8s? That seems a little odd to me. What is it? There's like no information at all. Additional information. That's just size and weight. Come on, man. What does it do? Huh. Brushed as fuck. Main unit set, MRO3 brushed. MHS unit? I don't even know what this means. integrated PN micro brushless, 18 pin, but not, yeah. And then V3 brushless is like the dinkiest one here. So I don't see any of these that integrate sensors that I know of. There's also just very little information about some of these. So I'm not going to go brushless, or I mean, not going to go censored. This thing, was this really $36? I don't think that's what I paid for it. I think I was dealing with pre-pandemic prices when I bought this thing. 12 volts, huh? 80 watts of horsepower. Metal aluminum. Bonk. All right, there. We got that out of my system. Managed to climb out of that rabbit hole. So what do we need? I need this to move down. Excuse me. Remove body. Oh, they did some kind of a sloppy cut that probably netted them a bunch of extra stuff. Okay, we're doing the threaded holes then. So let's go way back to the beginning here. All right, there we're doing the shaft. I hit cancel on that. Where else are we? Oh, here's some stuff. So we do a revolve, pin that down. What about this one? That's a pattern, so we don't worry about that. Oh, that's where they're making the wires, I guess. That's cute. That's cute. I'm looking at the steps where things are getting locked down, and I don't see... Well, those are just moves, but I'm looking for the pins. That's repeating that around a pattern. Where does this come from? Where does it go? There it is. I do. But I mean, God, I do. Comp 3, body, and then the threads. So what do I do in here? Edit feature, bodies, one selected. I guess I can jump back here and move it 2 millimeters back. So from here, we can roll the history marker here, and then I can do a move command on this and just move it 1.5. And then we roll it all the way to the end. Oh geez, the timeline's too large. There, that's more like what we have. All right. Now I got to figure out what to do on the end here. I need to do the pattern, and I guess we have more ribs than that one. We're not going to worry too much about that. Where are these actually being extruded, though? Maybe I can find that. That's a revolve. Ah. None of these are locked down. I feel like I'm being played for a fool here with these sketches. These sketches, they're like, what is this all based on? Is that okay? So there's a pattern in there. How many more ribs do we have? Then I gotta count these things. It's just weird that nothing is locked down. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 from, well, it's 9 across the entire body, actually. There's a couple more going forward. This one, they have it starting after the trough, but ours go for the entire duration of the thing. So 9 isn't going to be the right number. I don't even know what the right number is going to be, actually, to be honest. How many more can we put in the reverse using the pattern? Probably be 3 more going backwards. This isn't even like tied to anything. I'm taking crazy pills. This is like just freehanding everything. They couldn't bother to do a measurement? Oh well. This is, you know, maybe we should have made this on our own. So let me do a pattern in the other direction. Rectangular. I need this measurement first. So this one is an extent. Distance -10. Damn it. All right. Ruler to the rescue. From here Actually, we want the total distance, don't we? 2.004. I'm going to say 2 on this. So I'm going to grab that, and we're going to create a rectangular pattern, and we're going to go spacing distance, and it's going to be 2. Let's see, that's 3 going in that direction. That looks more like, oh, so we're going, wait a minute. That's creating 2, but they're, why would it create, it creates another one, but it does it in the wrong direction or something? Maybe offset? One direction, quantity. If I up the quantity, now we have 3 marked out. What is it doing? Wait a minute. It's making an extra one that's on top of the original one, I think. I don't know if I can offset it at all. Direction. This way. 4, 2 millimeter, one direction. That's strange. I don't know why it's doing that. Anyway, we'll just let it do that. And then I would have 9, but they're actually spaced differently. This is just aesthetics. I don't actually need to be doing this. But I do want it to kind of approach the thing. So how many more do I need in order to approach 20 millimeters? Well, that one has the extent as... This is what I don't like about this tool. The extent for at 2 mil... No, that's the wrong one. Shift and hold the click. Oh, come on. I can't even get to it. Fine, I'm not going to worry about this. I'm just going to Control Z. Get me out of here. Get me out of here. We're not going to worry about that. That actually does look relatively accurate. It's just we have a couple more up here on this on the new one. We also have different hulls in the front, but I don't think I'm going to do anything to accommodate that. See, we have double hulls, whereas that one has individual on each thing. I think I'm going to just leave that one alone. Because I think the hulls should be samey kind of spacing on them. So, oops. Control, oh, what is this motor even called? We never found a part number for it, did we? It's just Rocket Mini Z high torque metal. Rocket Mini Z. There's no other information. All right, so save that, and then I'm going to rename it. Well, 1525, maybe that's what it is. 1525 would be the dimensions of it. That makes sense. Now we need to do the back thing, so we need to add a sketch. Wait, what is this? What are you yelling at me about? What? You did fine. Everything is still in here. You don't have to be so self-conscious about it. This step is perfectly okay. Okay, there we go. I don't know, it fixed itself. So we need a sketch here. And then I'm going to project this hole. Can I even get to that? Oh, it's just, they didn't do any kind of, they didn't try to clean it up at all. All right, well, then we don't need to project anything. I'm not going to project anything if that's the case. They have the parts just sort of run into one another. So we need to make something that's similar to this, although we will want to be avoiding, basically all I need is a circle, but if I really want to get fancy, I can do all those, I'm not going to do the screws, but we can make 3 holes in the back. Looks like one just goes, okay, so one goes directly up, and that's got a particular offset on it and a particular diameter, and then this thing has four 3.8 We call that 4. Can we really? Do we get away with that? Can we call that 4? Not really. 3.9. It's gonna be 4. That's gonna be 4. The shaft size is 2, so I need a 2 and a 4. Oh my god! Look at all this stuff. Neat. Circle, center, 2. Circle, center, 4. Then we go and get the outside diameter of the main circle that's going to cut out, which is going to be 9.85, 9.92. I'm going to call that 10. 10. Then, and is it centered on that radius? I don't think it is. Chose the hard to see one to do. It does actually look like it is centered on that. Yeah, I'm going to call that centered. So those are what diameter? Are we calling that 4 or are we calling that 3.75? I'm going to call it 4. I'm going to call it 4. This thing has been designed with whole numbers for everything. So if I take a construction line and go straight up from here, .8. If I did the exact numbers, it would be so frustrating. 4. And so now we can make a circular pattern. Circular pattern, U. Center point, U. And 3. And there's that. So now I need another circular pattern for the screws, but that doesn't really stick out. So I don't really know if that's going to be necessary. Maybe we'll just put it in there so it looks like the right thing. So that's 2.5 millimeter. Yeah, 2.5. 2.5 millimeter, but it's offset 45 degrees. So we'll take a construction line and we'll put that in at 45. Oh, is that 45 degrees? It doesn't really seem like it is. No, 360 over, what are, oh God, geometry. I'm gonna open up calculator. Open up calculator. 360 over 3. I should have known 120. See if somewhere at 120, but 120 I think is going to take us like, well, let's just see, 120. That ain't right. What the hell? What's wrong with me today? I could cheat and do a midline. There, I cheated. It's, just because I couldn't figure out the geometry because I'm dumb. And then we create another circular pattern with this thing around the center. I didn't do well in that math. didn't do very well. Yeah, those are represented on the thing too. So it's like a little double point weirdo thing. Okay, so that's what I need in order to create that. So now I need to get the measurement of the height of it. Let's do one of these. Actually, I trust this better because they're two big flat surfaces. Are you kidding me? That's not a number. Are you serious? Are you serious? Brings it to 29. Oh, actually. So weird. That's such a weird, like, everything else has been really easily identifiable as a whole number. 2.31, 15.02, right? So why are you such a weird number? I'm just gonna do 2.3. I'll do 2.3, but I won't like it. Wait, oh, I missed. I keep misclicking. Okay, so that's our sketch. Now we're gonna extrude this piece 2.3. And then I'm gonna extrude this piece 2. And now I'm gonna go into the appearance menu. Well, first of all, I don't wanna look at that sketch anymore. Oh my God, so many sketches in this design. So let's see, the end of that shaft, is that noticeably chamfered? Not really. It does have a little bit of one. So does the outside edge of this stuff. So we'll give that a couple fillets. I always mix up the two. Oh, we actually are giving it chamfers. Oops. And then take this entire outer edge. It's full of little surfaces. Oh my God. All the clicking. So much clicking. I could probably double click and it would give me the whole path. How noticeably chamfered is this thing? Oh yeah, it's got a noticeable chamfer. Wait. No, I don't want fillet. Oh no! I gotta click all that stuff again. I could have sworn I chose the right one. Let me try double clicking. Nope, didn't work. I gotta click everything individually. Doot, 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 doot. Yeah, that'll do. So fillet, 12 edges, even fillet, good to go. And then I'm gonna go to the appearance menu and I'm gonna take their silvery color and I'm gonna do faces. And I'll just do this and then this. Close. All right, it's looking more like the back. Now we have a couple more things to do with this sketch. I have to extrude this, this, and this. And we'll just do like -2. Just to cut it into the body a little bit. It's a little sloppy. I don't want this to be in there, so maybe we'll do a little bit more shallow than that. Just to represent where the stuff is. It doesn't need to be totally accurate. This one will do like -0.5. -0.2. That'll just give it a little cut in for the, I don't know, to represent the screw. I wonder if I could have drawn like a plus symbol in there and made it. I guess I could make it into a little virtual screw. No, I said I wouldn't model the screws fully. I'm getting too much into the aesthetics. Okay, so there's our Rocket 1525. Our name is increasingly inaccurate. Did I not just click rename? Rename. There we go. Just Rocket 1525. Okay, so close enough. Near enough makes no difference, right, to the model that we actually have. And now our distances are accurate enough that I can design the electronics tray so that I can pack all of my electronics into a tiny little area on the RC car, and when I fucking flip it off the road or hit it directly into a curb, the electronics will at least have a layer of plastic to protect them, theoretically. So yeah, okay, so now we finally have the right motor. Let's get this into the main WL Toys design, but the problem with the main WL Toys design is it's really for this type of motor, this, you know, the brushed DC motor. I was going to do that for the Mario Kart thing, so I decided that I would build this with a brushed DC motor and use a 1S cell. We're not doing that. we're using actually a much more powerful motor now, where you've got the brushless one in there. So I think what I need to do is start over on this design and put all the parts that I have into the right positions so that I have a model that starts from here. And I think maybe the lower part of the servo, I might want to create a part from that. Like take this piece of plastic here, because this servo mount actually works really well. It just needs a little bit of modification to go into the main model. And I'm thinking maybe I want to move it just like a tiny, tiny bit backwards, just a little tiny bit. Because what I have in here is an old version of that. What is the old version of this? I think it's relatively the same though. It doesn't have that little chamfer, I don't think. And the servo's all the way up against the edge. And it's a long time ago that we did those streams. Well, okay, let's start somewhere, I guess, right? Why do I have PMs right now? People don't leave me alone when I stream. Wait a minute, why are you under suspicion for saying, what if you want to go back now? What the hell? What is that? How do I even control that? Look at this. I'm sorry, Kappa Votes. That's not suspicious. I can't do anything about it. You better watch your back, bro. I don't know what's going on there. You do a goddamn suspicious thing. Didn't do anything. Yeah, so this is made to mount my other speed controller, our own custom speed controller project. And I've decided to give up on life and let go of all of my dreams and aspirations and use the DOS Micro board. In order to use the DOS Micro board, I actually have to model the DOS Micro board. We'll do that in a bit. I think first we should put together a new model for the RC car. So let's do a bunch of, I guess, throwing parts at a problem and then working it out in the end. So I'm going to save this one as the WL989. Just call it start. And so we need to go into the folders. Into the folders. Oh, I saved this into the wrong directory. Hold on. I gotta fix my mistake. We gotta go into motors. And this, move. And we go up one directory. Yeah, right there, move. There we go. I'm trying to keep it together. Oh, this thing needs to move. Move that into the 3D printer projects directory, which I spelled out 3, didn't I? Yeah, no, I didn't. Okay, move that to there. Okay, cool. So, wheels and bodies, servos, screws, motors, Mario Kart, generic parts, electronics. Where's my stuff? Hey! Heg Pets, thank you for subbing for 19 months. Hey! Thank you so much, Heg Pets. Thank you for the 19 months. What the heck? Oh, I made like a size guide for the WL Toys kits so that I could try to fit bodies to things. And then I kind of ran away with it and made a whole huge there's a lot of stuff here. Those are just the electronics and what it took to put that together. Motors, normal Z, old Z cart. I don't think it's normal Z. Oh no, so this is for the Scorpion kit. You're being monitored as a suspicious user for some reason. That's what some moderation thing has told me. I don't know what you did, Kappa Votes, but something has you highlighted. Oh, WL Toys, duh. I'm dumb. This all starts here. So I'm gonna go to, that's work in progress, version 60, that's that one. Well, I need to actually open up the empty file. And we're just basically gonna drag and drop parts in. I don't know, something you did in another channel might have gotten you like flagged for being suspicious. Oh, and now my chat doesn't scroll every time you send a message. Perfect. Thank you, Twitch. I love all the new features. Has anybody else been having problems with VODs? I was watching a VOD and it wasn't loading properly. There was something up with VODs, and I think it's because they've gone into the system and they started rearranging the wires in order to do their new features, which allows, I guess, a 4090 to do, or whatever like super expensive video card can now do a little bit more with encoding. And I think we can finally use a different encoder so that we can actually see grass in a game. That would be nice, because I don't know if I'm touching the right kind of grass. I haven't seen video game grass rendered accurately enough on Twitch for me to touch. WL Toys chassis. Everything starts here. Plomp. All right. So this was painstakingly modeled by yours truly. I spent a lot of time getting this right. It'll be able to use a lot more than you think. Oh, well, I mean, in time, I guess, is the important part. So this took a lot of modeling. I actually put the chassis on a scanning bed, scanned it, brought the image into CAD, and then modeled out where all the screw holes went, and found out that there are mistakes. There are actually mistakes on these. This top bar has a mistake on it where it doesn't quite line up. Craziness. Now, the differential housing is a mirrored part, so we can bring that in. And then I can get the housing into the right position. Now, to do that, I'm actually going to use a point-to-point move. But first, I'm just going to suspend it up here like this. So what I want to do, I guess I want to mirror it and flip it around too. Getting all of these dimensions correct is going to be a little bit weird. We might defer to this model in order to get all that stuff properly placed. But I guess for now, I'm just going to line up holes to holes, and then the CAD program is going to want me to lock everything down in position, which I will do, but I will do that so that it pretty much just puts all that stuff into one step. Actually, what I should really do is use a move command on this and then lock everything down. But then I have to go into that move command and move everything all at once, so I don't know. I can bring in every single part at once. I can do this not as a copy. I can bring in this other diff housing. We'll just do it that way. I got to bring a lot of parts in then. That, and we'll get that over there, and I'll just lift this into an initial spot. Then I need, let's do 4 A-arms. I'll just get those into position. So those face which direction? They both face opposite directions, and the little circular cutout is whichever end they are, and they flip around for the other side. So click OK on that. So I'm just going to do this way and just get them all rotated the way that they should be. This one, in fact, needs to be moved downwards a little bit. What's going on here? I was holding down a key. Lately, when I've been streaming and doing stuff like this, I've been accidentally holding down Shift. Yeah, that is the right direction. Okay. Hilariously, these A-arms have a spot for a grub screw where you can lower the model kit, which is completely insane to me because the thing only has like a millimeter or 2 of clearance, and that's actually a big problem. So these need to be flipped 180 degrees and then put into position. We'll do this one over here. Click OK. Bring in another one. The top of this thing really should have proper A-arms. It's kind of annoying that it doesn't. Oh, cancel. I'm being careful not to use a move command here because then it'll want me to lock everything in. And once I use the move command, I will then have to go back into that command to move anything else in order to keep our drawing properly organized. Okay, that's good for that. All right, what else? There's a lot of stuff that we need to bring in. That one goes to this one. I should probably make a sub-assembly for that. But let's start from the bottom up, I guess. And then I've got my hubs, my different types of hub. Are those one part? That's going to be kind of annoying. There's a chart out there somewhere with how many streams each GPU can handle. Huh. I thought it was only for the 49. I think you had to have the big bruiser graphics card in order to do that. That was my impression of it. All right, do this. 90 degrees. This part is very weak. I don't know if there's something, I don't know if I should redesign it or not. It's very small and it's very easy for it to break and it's hard to print. Maybe I should design an A-arm. Any RTX 40 series? No. Well, that doesn't help me. I'm not about to go get a 40 series. Are you kidding me? That's for like rich streamers. What's up, Gonad? We're redoing the WL Toys 3D model so that I have access to everything. So I have a blank canvas to start from so I can actually build up some of these things. It's going to be 40 at first for AV1, but enhanced multi-res output was 30 and later. This has a 1080 FTW in it, this machine. One of the best cards ever made. But, well, the FTW specifically no, but the 1080 was a brilliant card, the likes of which we are not going to see for some time. So all of my spindles face backwards, and they're all the same type now. They're all this type of spindle. All I need to do is bring this in and then make a couple copies of it. Everyone who uses NVIDIA GPUs for Plex is well aware of how many streams different cards can handle. A 2070 can handle up to 6 transcodes. Interesting. Plex can do that? I don't have a graphics card on my on the machine that has Plex. Maybe that's why it's so slow. It is a relatively modern motherboard, though, so I think it has the abilities that it needs, but it can't do graphics card stuff. There was other documents saying that the enhanced functions would work on 900 series and later, but first pass was limited to 40 with testing. Ah. I see, I see. I see, I see. Well, maybe eventually we can make the 1080 actually work at something. Because right now it is practically idling and it's water cooled. It's water cooled. It doesn't have to be water cooled, but it is. We did it for fun. We'll take a look at how much my GPU is actually being used in just a minute. Let me just get these parts in here. This is a little tedious. This is the work part of the whole thing. This is like, it's virtually putting together your actual kit car. Even though the WL Toys come assembled, you really should disassemble the whole thing if you get a WL Toys, because it needs a little bit of love to work properly. It'll probably work just fine out of the box. It'll be a little bit slow, but if you go in there and you grease the right stuff and you make sure things are assembled properly, you get a lot more out of it. And at the level of modification that I have on the WL Toys kit, I've even replaced the differentials. There's not a lot left that's original, but it is a screaming fast RC car. I'm pretty happy with it, to be honest. Although it would be nice to do like a pan car, but 1080 Ti can do 9 simultaneous H.264 HEVC transcodes. Damn. Let me look at the task mangler and see what happens. See, I added another monitor, and then I added water cooling and the 1080. Where's the 1080? GPU, there we go. 20% utilization rather. We're around 20%. Uptime is 93 hours. Hell yeah. I should probably restart this computer. Okay, let's bring these guys in here. My sus linkages. 90 degrees. Where are the other ones? I don't want them to show up as copies in the thing, so I've been dragging and dropping each individual part. I could use like a move copy command, but then it shows up as parentheses copy, and it gets in the way of being able to view everything. So I don't know what the limitations are on the non-academic version of Fusion 360. You may have to have a file that has all of your parts in it, which would actually aid in doing this, where I could bring in all the parts from one file and it would be a completely disassembled WL Toys. 90 degrees. That's okay there. The symmetrical parts are nice because I don't have to flip them in weird ways. There's so much stuff that I need to be working on. That's why we're doing this today, because this has nothing to do with any of the other projects, and it doesn't get me anywhere forward from where I am right now in terms of building things. This is complete and utter executive dysfunction is what you're watching right now. I'm going to do the thing that's fun. Not what I should be doing. Battery holder, let's get that in there. And I don't know what orientation this thing goes in. There's two of them. And they go over here. So we'll pull one in like this. Move that over there. Click OK. I'll pull in another one. This is another one of those models that I had to reverse engineer the original kit. We still need the motor plate too. That's one thing we need to reverse engineer. 180. There we go. What's up, Remdog Cap? Popping in for a little while. Oh, cool. Oh God, I think I have like 400 emails in my inbox, and all of them are irrelevant, and I need to go through and delete like all of them. We have a new rear linkage. We need to model that. Let's see, what else do we have? Drive shaft and gears. Bring that in. I don't think there are gears on this one. That's the drive shaft. I don't think the gears are their own files. I think I built them in place. Oh no, unless I have a different, I think I might have one in a different folder. I know, some people have thousands. I keep a tight inbox. There are 3 emails that I keep forever, and those are follow notices from various people who are way more famous than I am. We need the top bar. Bring that all the way over here. This is like a deconstructed view from the manual. Now where's the big hole? Big hole is that way. So this goes this way. Usually it's less than 40. Listen, I've been ignoring my inbox for quite some time. Servo linkage. And then the steering linkage. What goes from spindle to spindle. Anything else that I need from this folder? I think that's everything. That's practically every single part there. Now there's much more to go, but I guess what I can do is start arranging these things where they go, and then we'll pull in stuff from the other files. It's better if we get it kind of organized. I don't know if I wanted. I really want to have one big move step though, so I'm probably going to have to reverse time to where everything looks like this. So actually, we should just take every single part in first. Every single part. There are my wider wheels. I also have narrower wheels. Those are the BBSs. Volvo R series wheels, but for the WL Toys kit. We'll do those because they look cool. We need 4 of them. Like that, and like this. Believe it or not, this is actually going to get us a much more organized file. And I guess what I could do, I could take a copy of the file before we start building bodies on it, and that could be sort of the starting point. I don't need to do that. No. I don't need to do that. I can always go into an old one and save off a copy. I just want to make sure that this file doesn't have all the baggage that the other one has, because we use that in order to create a lot of the solids, and doing that in situ bogs down the file. It's not that you shouldn't do it, but it bogs down the file in a way that I didn't want the file bogged down. So this one over here, move it back a little bit. Whatever, doesn't matter. So many little parts go into this thing. Okay, who's next? I think that's a different part. Yeah, this is a totally different setup here. Well, the motor. It's the old Z cart. What's in there? Oh my God, there's so much stuff. Oh, so this is where I actually modeled the axle, the ball differential. I will be needing that eventually. Yeah, these are all very old. Let's see. Generic parts. Oh yeah, there's the shock absorber. That's a near enough as makes no difference shock that I have. You can buy these on Amazon. They're all over the place. But I got two of these things that just basically represent what I have. They're not exact copies. Let's bring in the second one. Whenever you're ready. There we go. It's starting to get a little slower in loading these things in. Nope, Control Z. I clicked on the wrong thing. So I'm trying to make the initial, like when you click on that move command, all this stuff is going to go into these positions before they are arranged into the final model. So I'm just trying to get all this stuff right. Now there's a little cap for that. There we go, suspension spacer. I need 4 of these. Oh, I wasn't done with that. Ah, man, it's getting busy in here. Back to there, and then like that. Oh no, like this. 270. Yeah. This is a big assembly. Another one of these. $180. Ah, crap, I messed up. I messed up again. I keep messing up. All right, let's see here. Way back to here, and then we do like that. That's facing the wrong way. Yeah, there you go. Yeah, I know. It's looking a little bit like the blown up view from the instructions. This is when you unwrap all the parts for the kit, and you're like, holy crap, I don't even know what I've gotten myself into. And then you sneeze and they all go flying. I had to put Loctite on the screws for the spindles because they're all aluminum, and my screws, my laptop screws, they don't bite in a whole lot. And so the RC car kept vibrating them into oblivion because the thing is going a million miles an hour and all the parts are vibrating like crazy. It was dropping screws on the street, and when it would drop a screw and then explode because it's like the spindle no longer had anything holding it into the right position, so it would just go psycho. Drive gear, move that over to the side and forward, even though it does actually go in the middle. Is that the right direction? Yes, okay. There's actually something in the back of this thing that fits into the differential gear. It's like a different kind of gear, but I didn't model that because I didn't need to. Motor spur. Bonk. Nice brass spur gear. I could change the gear ratio, but I think the direction that I have to go in would make the model slower, which, you know, probably is a good idea. I don't need the torque. I can already spin out all of the wheels very, very easily. Oh, the switch. I haven't wired this up yet. I need to do that. It would be nice to be able to turn it on and off easily. I don't know what kind of current these switches can handle, though. I feel like it's very much outdoing... I think the motor... Didn't we see it draw, like... No, we didn't see... No, that was the fan motor. That wasn't this motor. I don't know what kind of current this motor draws. It's probably something like 2 or 3 amps when running. I don't know when else... Here's my battery model. It's just a lump. My 2S battery. Put it over here. Battery. I need 4 bearings. Oh God, I can't even see this stuff. Actually, I probably need 6, but I'm just gonna model 1 bearing. We'll just put 1 bearing in here. Technically, there's 2 on each of these, but just to get the wheel placed properly. This makes me just want to build it. I wonder what the price tag would come to buy all this stuff just from scratch right now. You'd save on shipping at least, because I bought this stuff piecemeal. I bought this stuff bit by bit, and it slowly adds up over time. And then I don't realize how much I've actually spent. I might as well have bought one of the super professional kits instead of this dinky WL989 and then upgrading it. All right, one more. I could be playing a game where I assemble stuff like this. RC car simulator. I remember seeing Groovy play one of those back in the day. This is the wrong... That's the wrong bearing. That's the wrong bearing. I did the wrong bearing. I only need 1 of these bearings. This is the drive shaft bearing. Totally wrong bearing. I am mistaken. I need to order some of those wheel bearings, because I actually had to take them out of the old wheels. I think they're the original ones that came with the WL Toys kit. That wouldn't be as fun, buying the expensive kit. I think it would be, because you get it disassembled, right? You'd be spending all this money, but then you could actually assemble it and make sure that everything was done correctly. I don't know. It's a debate. It's like I'm halfway between both of those ideas. What else do we need? I need to make a linkage out of this one and this one. Oh no, not the filed in one, just a regular old ball joint. Oh, I forgot that some of them are filed down. Huh. We're not doing that anymore. Mass producing the parts would be its own set of... If I had like a CNC that could do this kind of stuff, I don't know how they are cheaply creating and anodizing all these little RC car parts, because they're so specialized, right? You can't be selling that many of these kits, unless I'm mistaken, and this is a lot more popular than I thought it was. Oh God, which servo was it? One has wings and the other one doesn't. And I've got both. I've got both because I accidentally ordered the wrong one at one point. And it doesn't really matter that much. I've already got provisions for it. You see here, the 3D printed part has a little cut right there so that it doesn't interfere with that wire. Oh, great teacher, how can I teach myself electrical engineering or electronics engineering? For me, it was exposure therapy. I'd take stuff apart and want to do modifications to it in order to get it to do the stuff that I wanted it to do. Hence the project that you're looking at in front of you right now. Other than that, I mean, there are courses that people can take now. It's been a long time since I've actually taught myself the electronics stuff. So, you know, there are books that you can get. YouTube video series everybody is trying to teach electronics now, and there's like a wealth of resources available. I don't know what they are because I don't live in that space. I get asked this quite a bit. People ask me, "Bother, how do I learn electronics?" And I don't know. I don't know. It was a different world when I learned electronics, right? Everybody was doing stuff in 7400 series. The basic stamp was having its run, and it was the king of the hobby scene. Nowadays, the Arduino is waning a little bit, but it's the waves of like innovation that it created are still there. They're still in the background of all of this stuff. A place to start would be with a basic Arduino kit, and they are not expensive. You can get a basic Arduino kit, and then you can look at some fun projects to build and follow step-by-step instructions. And there's just an incredible wealth of things to learn in that realm. It depends, though. You can go a couple different directions, and there's a lot to electrical engineering and electronics projects. Generally, where I started was just, what do I want to improve, and sort of building up that skill. But like having an Arduino idea is one thing. If you want to learn the nitty-gritty and you are well acclimated to math, there's a lot of math that you can learn, and that's what I found out in college, is that my math wasn't up to snuff, and I needed to learn a lot of concepts and things like that mathematically, because the basis of engineering is trying to solve a problem at its lowest level. But in terms of like hobby stuff, you take two projects and smash them together, and now you have a unique thing. So there's a lot in that realm as well. There's a lot of digital encryption and stuff like that out there. There's a lot of like programming to learn. It's a lot. So I mean, I guess just take it easy and just try to hone in on a couple of things that you want to do first, and take on a project that's just a little bit more complicated than you understand. And I guess getting an idea of what that means may mean that you probably have to go out and get like an Arduino kit and start seeing what you can do with the stuff that you have. But not everybody learns the same way. So what works for me might not work for you. And that's okay. So let's put in one of the servos with the wings. I'll grab this one, plop it in. It's kind of a tough question, yeah. Kind of a tough question. Now our servo is the opposite end of the hole. Yeah, it actually goes right here. So let's flip this around and just put it in a position with all our other stuff. Man, making this model is a lot. It's pretty extra. There's a lot of stuff to do here. What have I modeled from the Mario Kart? I guess I have a bunch of stuff. Not all of that's relevant, though. Yeah, there's a lot of junk files. Oh, so this is where I tried to widen everything from the Scorpion kit and make that into a Mario Kart. I can probably delete that whole directory. Lego CAD. Not quite. Not quite. Parts. It's just normal parts. Normal kind of CAD. Wait a minute. Where'd you come from? You. Delete. What the? How did it survive? You. Maybe Control Z, because I don't know what I just deleted. Then we can repeat that step. I'm going to go over to here. Yeah, don't be a self-doubter. Don't be a self-hater. Most of all, have fun. I guess I got two in here that I didn't need. There we go. Oh, okay. Look at my RC car. Bunch of parts on a table. Okay, let's see. What is next? What are next? We've got almost everything in here, I think, except for some of the stuff that I designed in place on the other drawing. Now, I don't have the part that holds the motor, so that's something that we need to model. Now, I have an extra one. I have, because I'm streaming this project, I have like 2 model kits worth of parts, which is good when you crash as frequently as I do. So I'm going to get the other thing. I'm also going to move my legs. If you guys have been sitting this whole time, move your legs. Move them around. Did I model screws in this one? No, I just left things float, as I should. Because modeling all the screws was completely unnecessary. Modeling them here, though, was a matter of clearancing things, so that had to be done. Yeah, I think that's all the parts in. I think we've got everything in there, except for this part, but this part in reference to the actual part that comes with the kit, not something that I'm going to 3D print. Although this would probably mount the 3-phase motor just fine. And actually, it would be interesting to make one that moves the entire motor back a little bit so that it can contact this gear with the wider holes. There's 2 sets of holes here. You can mount this drive, the axle, in 2 different positions. One is much wider than the other one. The way that the drive shaft fits in, though, is with the rear in the narrow position and the front in the wide position. And I guess I could do the two of them all the way in board, and that would probably be another way to do it. But yeah, look at all that tilt. My God. That's it. That's the amount of tilt that you get. That's it. There's like no suspension movement in this model kit. It's ridiculous. Utterly ridiculous. Okay, so let's go back to there. I'm going to save, Control S, and we're going to make a new part. So let's get the part that we're going to make. I do want to do more reverse engineering with Dave's thing. I think the part that the voltage controlled amplifier, it's on its way. I don't know where it is. Should be getting here any minute now. Any day now. I can't believe I broke one of the differentials. I crashed and the metal drive shaft just straight up broke the differential, like the dog bone mount of the differential, and that caused me much anguish. Because it's a plastic part and the differential's in the middle of that housing. That housing is like impossible. The housings are the first thing you install on this kit. So to get all the way down to the differential is like really difficult. So here's the other kit that I have. It's full of dust because we haven't done RC cars in a little while. And there's at least the initial motor mount design. Has an extra hole there for a, what do you call it? For the rear mount for the other type of motor. But yeah, this is no bueno here because there's no mounting holes. There was a different plate that fit into there that I would use. I could actually extend that backwards a little bit. That would be interesting. Oh wait, that's not the right part. I need the, do I have it in any of these? Where's that? Is there another? Oh yeah, here. Might have it in here. Which one of y'all is a motor plate? Those are all the body plates. All the old arms. 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 Like I said, when you do the metal parts, you have to order multiples of the metal parts, or else sometimes you get like a joint that binds because it's so poorly made. So I've had to buy multiples of everything. I have too many RC car parts now. None of these are that motor plate, huh? What's over here? Hold on. Underneath these plastic bits. These things are hatefully bad. These things are really, really bad. Actually, wait, that one's locked. Yeah, this one's a locked differential. I guess that's for the drift car? Is it locked or is it just really bad? I think it's locked. How about this one? Yeah, it's locked. That is a locked diff. All right, none of y'all are what I'm looking for. You go back in here. That's another bumper. That's not it. All right, so the only other place it could be, I guess it could be in the tray, the RC car tray that I have. Let me go take a look. There you go, take a look. I would have worked on whatever we didn't get to today, tomorrow, but I'm going to be uploading videos all day. I'm thinking about getting up early and just spending the whole day uploading video, because I have to go through and mark all the things that happen in the video. Do I not have any of those motor plates? That's crazy talk. I don't want to get the one that I have right now, because then I got to tear the model down to its bones. Looks like that's my only option, though. How did that happen? How did I get here? How did we end up here? Where I don't have a particular motor bracket that I have multiples of. I guess I only have two of them. They came with the original WL Toys model. Let me check the other RC car bin to see if it's in there. It may very well be. That very well may be. Let's see. Yeah, okay, it's not in there. Okay, so let's look down below. I have like 4 places that there are RC car parts, because I'm totally organized. All right, so here's the Scorpion Redux, and we bought these incredibly scary motors. These are 12-volt motors. They put these in Nerf guns. And like totally overcharge them. These are rare earth magnets in a regular DC motor housing, and they're frightening because they're such powerful magnets. It's like really insane. And it draws a ton of current. Just an absolute boatload. Those are joints that I can't use. Batteries. A radio. If it's anywhere, I guess it's going to be down here. Oh yeah, these are the original WL Toys tires. So they expect you to get all that power through these little tiny, eeny-weeny little wheels. And I guess that's okay if you're using the original motor, but it's not good for what I'm doing. Those things would be like sheets of glass out there. I don't see that motor housing. What happened to it? I bet you it's been rattling around in the shop, and I've been annoyed at it getting in the way, and I did something like throw it away. I don't think I threw it away, but I might have. WL Toys stuff everywhere. It's not in this mess of wires. I have just like random wires sitting in the bottom of this bin. Servo linkages, random wires, and a speed controller that is not really worth it. The DOS Micro one is so much better. What's in here? Nope. How about under this thing? And this is all the old servo stuff. Wait. Oh, this is the broken axle. Put that up there. Guess I never wondered where that went. All right, no luck. No luck finding it. I guess I'll have to take the one out of here, out of the current model. I didn't want to have to take that apart, but if I can't find it, I guess I got to. So it ended up in here for some reason. See, I think I remember seeing it somewhere, but the memory is fleeting and it escapes me. I do not know where it is. I have a mental map of where everything is, and it often fails. I know some people are freaks and they like catalog where everything is in their shop. I'm not a freak. I don't do weird stuff like that. I just lose things constantly. Like a normal person. I wonder what happened to that housing. I'm tempted to look again, but I don't think I want to misplay. I don't want to waste all y'all's time. We need to reverse engineer that plastic part, and I'll just get the other one. just going to take one last sweep. One last little sweep. Because I've got the old servo mount right here. But I don't have the old motor mount. Old servo mount, check. Motor mount, no check. I also have all that camera stuff that Louis wanted me to buy. Lunatic Live. Said all that FPV stuff is awesome, and I happen to have a lot of it. Nope, nothing. Okay, coming back. Yeah, I don't know where it would be. I don't know where that would go. There's only so many places that I've stashed stuff. Dad Deets, thank you for the 63 months with Prime. How's it going? Okay. I only have one of these motor mounts for some reason. So we have to get all the way down to this thing. All the way down to this thing, which requires a screwdriver and a devil-may-care attitude. What I'm hoping is that we can build up this setup and it will allow us to model an electronics enclosure that I can print and get everything mounted to and keep it low enough. What up, Chimera? So unfortunately, I no longer can show off the fully assembled RC car because I have to take this stuff apart in order to model the one housing. So we take off the top bar first. It's kind of a dumpy, rainy day here. We're getting a lot of rain, and I don't know. Even my dog was acting weird. She was being all weird because we had electricians here installing outlets. While I can install an outlet perfectly fine, we had somebody come over to do it because I don't want the liability. I don't want to be responsible for whatever the hell happens to the outlet. So I'd rather have a professional come in and do it. But they kind of traumatized my poor dog, which by all means she shouldn't be traumatized, but she just was acting a little funny earlier, just because I think she had too exciting of a morning. Too much excitement, too much to bark at. So we're having a quiet, traumatized, rainy day, which means working on the RC car that I was trying to get a video of. I kept trying to get a video of this thing going top speed, but it's hard when you're the only person holding the camera and you don't want to completely dox yourself. That's the tough part, is the doxing. All right, so the whole rear housing comes off. Woo! Look at it go. Oh my goodness. Okay, put that aside. Stop playing with it. Stop making fun. Stop it. You stop that. I guess we got to model it like this just because I would have to desolder these to get this thing free. So we already know where our motor's going. We just need to make this housing. Now, where do you think we should start? I mean, I guess I can start just from here. I don't need to include this, but I probably should include that. And then there are some shapes in these regions. I don't know how we're going to be able to get those. Looks like that's a radius. There's a lot of design that went into this that really didn't need to. Really kind of didn't need to. All right, so new document. We have a new part, so this will be a WL Toys part. Did I already model the motor housing? No. I could have saved myself some trouble and done this in the past. Let's make a new part, save it as motor mount. All right, so we start from the beginning. Let's start from a sketch that we're just going to put. I guess we should probably work from here. Yeah, we'll work from here. We'll work straight on and we'll extrude backwards. Center point of the part. I don't know. Kind of asymmetrical if you ask me. Here, we'll do this. And then I'll turn on the microscope. Even though that'll be kind of tough to see, but. Hold on, that's got to go behind Streamlabs too. Do you model each part in a separate file and assemble in one? Or do you design stuff in place so you can project dimensions? A little bit of both, actually. With Fusion, a little bit of both. The way that I like to organize my drawings is that the first step is where you pull in all the parts. So all the parts come in as the first thing, and you can group them into one like collapsible step. That's how I did it on this model here. So this one, you can see there's like 10. Why are we viewing this upside down? What's going on here? Why did our view get all weird? This right here is where I'm pulling in every single part that makes up this thing, and I can collapse it. And then I have a step where I've locked all the parts in place. So if I move any of those parts, I need to move them here, because the next couple of things that are designed in place using all the positions of the parts that I've just put in. So there's a part, there's a part, there's a part. This, unfortunately, this drawing has gotten a little bit mangled. It's a little tired of our BS. So we're kind of starting it over, and that's what I'm doing here by placing all the stuff down. When I start to use move commands to put them all together into the frame, here, let's see, the microscope's in the way now. When I start putting them all together to make the frame, I will then lock them in a position and I can move on from there. But I didn't stop the other file. I guess I probably could have taken the other file and taken where everything is put into position and then deleted all the steps after that and save off a different version. But I also want this part, the servo mount part, in my new drawing. So what I'll need to do is export this as a component, and then I'll pull it into the main, or the new one. Yeah, listen, if you can get an F3D file, you can see how other people make their parts too. And there's a lot of stuff that I don't like. And it's a lot of the stuff that I will do if I'm being lazy. And we saw that with the motor that we modified. We modified this motor to resemble our motor in the rear dimensions and the placing of the poles. I don't know about the screw holes, are probably not going to be in the right spots. But the rocket motor that I have is a sensorless one, and we modified this drawing, and we got to see how this person created their timeline's a mess too. I mean, you know, everyone's timeline is a total mess. This became a little bit too heavy. All of this stuff here that was done afterwards. So right now what we're doing is we are starting a new file to make this part, but the one that resembles the actual WL Toys kit motor mount. What's the brown thing? Oh, here? Yeah, that's sort of like a representation of the spindle. It's not accurate. It's just done there to kind of look like a spindle. They took like a ring and they rotated it around. They made a repeat like around. Yeah. I know motor mount is misspelled. I almost never spell stuff correctly. That's what we do here. Okay, so we got the part out. Yeah, we got the part out. I don't want to unpress the motor right now, which is probably going to be a problem. That'll probably be a problem. We could start here and work our way out. We know the dimensions of the circles, but I don't really know the location. This thing's kind of a bitch of a part, isn't it? It's kind of annoying. I'm kind of annoyed at this part. Because then I got to figure out what that angle is. This is probably the height of the other one, the little clip over here. I don't think I fully rendered that though. And then we've got an overall height, but then we have a circle coming out of that mount. What the heck? Oh my God. This is horrifying. All right, that's a nice even number though, 17 millimeter. 28.5. Come on. 17 by 28.79. Are you kidding me? I'm not going to make it 29. So this one would be 1728.5. That's our overall box. And then at a certain point, we have this thing turning. Actually, what the heck? Well, that's rounded there. So if this is flat, then we'll put fillets on those ends. So this thing would be 11 or 10.5. Why are the dimensions so annoying? 10.5, I'm going to say that is. And the thickness is 1.5. 1.5, 10.5. All right, all right. So another one here, and that's 10.5, 1.5. And then we have another dimension. You guys can sing the Beastie Boys song on your own. I won't subject you to that. No more will I be singing on stream after what I've had to listen to in my VODs. The VODs are going to continue to be uploaded, by the way. I hope I don't miss any days, but the actual date is starting to creep up on my upload date, which is why tomorrow I need to sit down and do as much as I possibly can do in terms of uploading. Am I satisfied with 21.5? There are so many halves on this thing. But it's like a rounded dimension. So, oh, we had microscope on the, that's right, I meant to do this. I meant to have the microscope up here. Hold on, I gotta click on something that lets me see my OBS. Put the microscope up. And now I can do my little measurements. You guys can sort of see it. Not really, though. Yeah, how do you get that dimension, though? Because it's like, it's rounded, right? So it's going to be somewhere around here. Somewhere around this location. And I'm getting 22. Maybe we'll take 22, and hopefully that'll create what we're looking for. So if I take a construction line over here, you can do that, but then you have to deal with the lens. You have to deal with the camera lens, because, I mean, you can even see just right from this camera, from the Logitech Brio, you can see that, and you got to be kind of sensitive to it, but like if I hold a ruler up to this, you'll see the ruler bend. See how it's concave at the top and the bottom, just barely? Yeah, see, that's really prevalent. It looks really bent here when you compare it to the bottom of the screen. So taking a photo can work, but it's easier just to look at it and figure out the dimension. You know, I'm basically trying to reverse engineer the way that they went through this and got all their dimensions. And it's probably not going to be incredibly accurate, but it'll be good enough that we can engineer around it if we need to. A lot of the thing is like this just places the motor in the right spot, and it looks good with the rest of the model. Wait, no, it does this, doesn't it? Where'd it go? Oh yeah, it's always tethered. Yeah, wait a minute. I don't know. Look at how that does. Look at how it do. It's actually going from a point that's inset a little bit more. And if you imagine it without that chamfer there, we're looking at, see how close to a round number that is, because we're going from like there to the outer edge, and I get nothing. It's all right. The calipers are always on. You're just turning on and off the screen. 4 millimeters in, or 3.5. Get me out of this tool. What's going on? There we go. That seems like kind of a big distance, though. By the time you do all that work, you might as well have just measured it, though. You might as well have just measured it with approximations, because that's what you're going to be doing in the end anyway. You're going to be approximating everything. Fusion 360 does let you import a photo, but by the time I get a flatbed scan of this part, I would still be worrying about all the different measurements that I need to do. I'd still be worrying about that. Placing those holes is not going to be fun. Actually, we can base it on the dimensions of the pan. We can measure it on the pan, and that way we'll know they'll fit. We know they'll fit. Yeah, that's going to be a separate sketch. We'll extrude this stuff in there, and then we'll go from the top up, and that'll help us do that. Let me get the bearing out of here. You can measure where that comes from, where it goes. Can I do? But I bid can I do? All right, there we go. How do I locate you? I mean, I guess I can do an XYZ off of this point from this model with my own housing, the one that I designed in there, and see if they line up. Alternatively, I can just measure and do the best I can and see if they line up in the final thing, and then we can do little tweaks to it if we need to get it exactly right. This might be a more specific number, so I probably need to put in whatever I measure instead of approximating. And we'll have to see how that matches up to the actual 3D model. 8.5, though, I'm feeling on that one. I'm feeling an 8.5. Actually, let's get a better dimension. Let me get the radius of this thing. So that's a 5. So that's 2.5 to center. 2.5 to center. So 1.5. So 4. 4 by 8.5, I think, is the location of the hole. What up, Carlos? Or rather, the bane of. So 8.5, which is actually where it's settled on, by 4. Like that. Hello? There we go. And then our outer radius is 5. And our inner radius, we're having a rainy day. We're having a sleepy, rainy day where we work on the RC car project, because it's actually pretty popular, to be honest. As my relevancy and popularity wanes. What the hell is that dimension? Let's use a drill bit to figure that out. That'd be a little bit easier. And then I'll have to get the motor off. I do think I actually have to get the motor off. I have a RC motor setting kit, but it's in the mail. It hasn't arrived yet. Needed it today. I didn't think I'd need it for a long time. I didn't get good shipping. Much smaller. I'm going to try to size it up with a drill bit and see if I can get a measurement that way. Push comes to shove, I guess I could just do it visually too. For the tip of space in to auto-convert in Fusion, it has come. Thanks for the tip of space in to auto-convert in Fusion. Oh yeah, to actually just write it in. Isn't that awesome? There we go, this is the size. Yeah, you just type IN. You can probably use a bunch of other different kinds of measurements too. It'll just convert it into whatever your settings are for that model. And also, one of the ones that I almost never get to show people that has been extremely relevant, especially when pulling in other people's documents, is to go into the document settings and you can change the units right here. I didn't know that's where that was. It's one of those things where Fusion kind of works in layers, and you need to know the specific layers and how to get there. So that's 3 millimeters. Okay, so we have that dimension now. Yeah, switching modes on the calipers is less reliable unless you lock it down. But that's something that I've been guilty of too. But that button's hard to hit. So this inside diameter is 3 millimeters. 3 millimeters. So we got the 3 millimeters in there. We got the 5 millimeters. Now we need a motor slot. How the hell is that going to happen? Well, I'm going to have to unseat the motor. I was hoping I could find the second one of these parts, but I don't know what happened to it. I don't know where it could have gotten to in the shop. I'm trying to like do like emergency, like think of, like where would it, I looked in all the places where it would have been. I don't know what happened to it. Yeah, math in the input is also when my brain doesn't work properly and I'm desperately trying to figure out, like, subtract this from this plus that measurement. You can just type it in, and if you go in to edit it, the equation's still there. They might monkey with the equation just a little bit to kind of like make it make sense for themselves, but you can go back in and reset some of your stuff. You can set a dimension while assigning it to a variable in the same field. So I was told not to ever use, I think it was Dinsdale, was like a huge, whatever the opposite of a proponent is, antiponent, of putting dimension, like putting variables in there. You can have stuff follow variables and equations, though. Yeah, he is a bit of a hater. You can have stuff follow like equations, so I could have like my outer diameter tolerances I could put to like a variable, and then I can change that variable depending on how things go. I mean, usually I know how I'm designing something and kind of follow my own rules, but yeah, if you want to play with like screw tolerances across your design, engineers and spreadsheets, that would basically be in what the hell was that menu? It's you go into modify, change parameters, and then you can make all of your parameters in here, and then you can assign those in the rest. Yeah. Yeah, 3D printing and tolerances. For me, it's just I know my printer, and I know it's plus minus 0.2 for press fit versus, yeah, whatever. But for enclosures, yeah, you guys seem to like to use it for that. Can you show the window? Sure. It's in modify. Here, let me get the microscope out of the way. Microscope, go away. Excuse me. Modify, change parameters. And then you have user parameters. Double click on that, I think. And you can, that's filter. How do you add one? Nope, I'm messing up. I'm messing it up. Next to the filter. Oh, okay. So it'd be plus. And you enter the name of the parameter, the units, what you want the expression to be. I guess you can use ABC, you can use variable names, and then you can leave a comment on it too. Very powerful if you're really trying to design something specially. What I normally do, though, I don't use those. What I use is the timeline, and when I go back on the timeline and I say, oh, I need to add 0.2 to this or 0.1 to this in order to get stuff to fit differently, I'll go back into the timeline steps, and sometimes it's multiple steps that you got to go through. The burn the subs designs are cursed. I don't even know if they're going to load into Fusion when I open it up again, because if something's slightly changed, it can blow up a lot of the rest of the stuff. We're doing a lot of cursed Fusion for that. Set it directly when dimensioning something like a sketch 2. If you hit D, you can then type it in width equals 10 millimeters, and it will set it and save the variable. Oh, cool. I didn't know that. So the dimension, you hit D, and you can say width equals 10 millimeter. Huh. Oh, but that's in the dimensioning, like when you're actually, so if I hit D to dimension and I go to this, that's going to over constrain it. Yeah, cancel. Sorry, I'm already completely constrained. If I do, hold on, let me try it. Do a circle, and I dimension. Ah, no! Bring me back. Bring me back. I want to go back. Okay, hit D, dimension, click that, and then width equals 20. Now, if I go to modify the parameters, I have one that's called width, and it equals 20. And then I can delete it. No, I can't. I can't delete it because it's being used. That's pretty cool. So you don't have to call it width. You could call it anything you want, but. Okay. We need the motor hole. I need my motor hole filled. So let's unseat the pinion on the motor and get that off of there. Currently, my best way to do it is to put it up against, I think, a washer, and then just hammer the middle of the pinion. I need a metal washer that'll get around that pinion and support most of it. Until my actual motor kit comes in the mail, which is unfortunate. Let me get my taps here. I think I have one that's small enough. Width 1, width 2, width 3. You want to be descriptive in those. You want to be a little bit descriptive. Your future self thanks you for this. This one has been bent. I just bend it back by hand. I don't want it to break and then hurt me. This is frustrating. This thing is bent. It's bent as hell. I don't know how to fix that. I'm about to do a pro gamer move here. I'm gonna call these all the same thing. I'm smart. These are hardened, so I'm kind of afraid this is gonna shatter. Whoa, jeez. Close. Need a little bit right there. Getting better. Getting worse. That's pretty good. It's still off by a little bit, but S-shaped screwdriver. I used to have one of those. The ones that were just the little 2 right angle screwdriver bits. A hammer. Oh, I have one right here. Well, this is that's kind of a letdown. The nylon piece is long since disintegrated. I guess that'll be okay for unseating a motor. This might be too thick, actually. Yeah, this pinion gear does not leave a lot to the imagination. I guess I get the screws out first. That's not going to give me any extra room. This is awkward. Oh, was the joke S screwdriver? It seems like this needs something that comes in from these 2 screw holes. Like some kind of like a gear puller, actually, like a miniature gear puller would do. I don't have a gear puller that's quite that shape, though, so I need to find like a piece of metal that's thin enough to get in there. Like a pair of pliers that would have these wide jaws on it, something. But that would just bend my pliers. That would be cruel. What I used previously to do this was a little wrench. It's not exactly the right tool, and I've got the right tool coming in the mail. I used something like this. That's actually too thick. Never mind. It's just a stamped wrench. Where'd the other one go? Did it make it back into the... I might not have made it back into this bin. Oh, that's the worst. Is when tools don't go to the places where they should be, where they're most easily found. So I need something that's going to support... There it is. Okay. This might be too thick as well. This is as thick as the washer. How did I use this before? what I did is I took the vise and I put it on its side. So vise on the side, because it's a little taller this way. Open it up so it can support this. And then I worked, how did I do this? Well, that's only going to do that. It can't quite get around it. But I think that'll do. So I need this to open up so that it'll drop in. Now, if I hammer on this, it will be mostly on the plastic. So I do have to be a little careful. But I think it'll give up pretty easily, and hopefully I don't smash the part. And then give it a little bop. Not quite. That didn't move at all. Okay. There we go. Sweet. See, without stressing out the motor itself, we don't want to push on the bearings. It's not meant to take force in that direction. It's really meant to take force in the side direction where the gear is going to be pushing on it. That's why it doesn't have thrust bearings in it. Hell, this thing probably doesn't even have bearings. It probably has oil impregnated bushings. Don't get too excited. It's just a term. Okay, so I have 3 slots, I guess, that I need to model into this thing. 3 sloots. Let's get that modeled. So I will need to, first of all, put away my tools. They're all over the place. They're getting in my way. I think what I need to do is take this from the outsides of the 2 radii, and then that'll give me the location on the rest of this thing. So I need to first figure out the radii, so that's going to be this width. Does it go by diameter or radius? 6.82. Am I going to call that 7? I think I'm going to call that 7. .75. That still seems like a bit of a stretch. Why can't any of these numbers be logical? Now, that is not even centered on this part. How in the world? Now, it should be probably 15 millimeters from there. Now it's 18.2. This part is going to be the death of me. This is a very strangely laid out part. It might be that this distance is probably going to be a certain factor, but okay, let's see here. Where would that motor be? What decisions made this motor in the position that it is? I can't come up with any. I think it's just crazy town. Crazy, crazy, crazy. Maybe they're having a laugh. Maybe that's what's going on. That probably has a good width. 5.6. 5.5 at a distance of 12.5. Yeah, 12.5, and then I'm going to say that's 5.5. 12 and a half, 5.5. Construction line, take it from here. We go 12.5, and that's not construction. I need to make that construction. 12.5, and then we're going to do a box. And then that's 5 und 5. And lock it in right there. So that would be the cutout for the like the outside dimension, but like in there is where we have our two ovals for screws. So I'm going to look at those first. That's a pretty strong 2 millimeters there. 2 millimeter offset is 2 millimeter, and the overall width is 3.5. So we're going 3.5, so it's going to be 3 millimeter. That seems a little tall. What was the, it was, okay, it's 2 millimeter for the size of the slot. So that would mean the outside radius of 2 plus 1. Wait, but that makes 1.8 and then that's 3. That seems way too tall. The diameter is 2. You take that down to 1, and then we get, that just seems too far up. Well, let's just see what else I can do with it. Okay, hold on. So if our outside radius is 2, then this distance of 3.5 would be minus 2 to get center to center. 1.5. So 0.75 in either direction. That seems really weird. Okay, hold on. This is blowing my brain up. Why? Why did it go at an angle? Maybe that in either direction. Why did it do a big... What the heck? It put a little line segment down because I clicked too long. Gotta be careful of that. You gotta watch out. 0.75 in either direction on a 2 millimeter slot. And then if I just take slot and I do a 2-point center to center, boop to boop, and then that's 2 millimeter. That's our screw hole. I guess that makes sense. And then the height of the next one would be the center that I could make the second screw slot out of. So what I need to do is go and take a measurement of this width. Ah, damn it. I'm going from the flat line on the bottom here. So I get this width as... Are we calling that... I don't... That's so close. That's such a weird number. Like, it doesn't quite fit with 7. I guess it is 7. Yeah, I think these were new calipers. I mean, these should be pretty accurate, but... so... 5.5, 5.6, 5.75. I don't think I can quite justify. Oh my God, this is another cursed number. This is another this thing is just made out of cursed numbers. Well, maybe we should look up motor dimensions and see what we can derive from that. It's like, I want to put in the very specific numbers. Like, maybe this is 5.8. It's a little closer to 5.5, but that's going to move everything subtly around, and it might not quite match up. I guess I'll do 5.5. We'll take that as a 5.5, even though it doesn't feel right. We'll just see if that works out. So that height there is going to be 5.5. Oh, that's right. The width is... Hold on a minute. What am I doing? What am I doing? This one was 7. Yeah. So half of 7 plus 5.5. Let's put an equation in there. So I'm going to go from here to 5.5 plus parentheses 7 over 2. 9. I could have just measured it as 9 millimeters. Is that even with this? 8.5. They are slightly different heights, so. Okay. And then it's 7, but then what's the overall width minus 7? 8.5. It's basically the same thing as the screw hole, huh? I should have predicted that. 0.75 in either direction. So take a construction line again and go 0.75, make sure that that's at a 90 degree. I'll do the same thing again. This is like, there's probably a way to reduce the redundancy of this, but I'll just put all the numbers in there. Why did that give me a checkbox? Is there a line segment in here? Nope. Okay. Got to watch out for those rogue line segments. Center to center, non-construction, here to here, width is 7. That is our motor slot. And then we're going to take this and we are going to mirror it on this line. There we go. Now, what is the distance between the center here and the center here? 12 millimeter. How can I get to around, because those are all threaded. Modeling threaded holes is very annoying for the person like me that has to go through and reverse engineer it all. 10.15, and we got a different number, didn't we? 10.15, and we got 12, which actually makes sense because the motor doesn't really fit in. I have to get creative with the screws in order to get it to fit. All right, and then I've got like a curve on the top there that brings it out to 18 millimeters. So I guess I can take this center and bring this up, not that, bring this up and go 18. And I'll do just a 3-point curve on that. Arc, 3-point, U to U via there. That looks stupid. It really does look stupid. Okay, I think that's everything that I need there, except for those little cut-in pieces that I don't even know if I'm going to model. I don't know if I'm going to model those. These things. They're on the other side too. I mean, they're cute and all, but we don't really need them on this. Plus, I would need to get... Well, I mean, I guess I can generate them. They're all softened up, too. They're all chamfered to within an inch of their lives, which is really strange. These are not that... No, they still have chamfers on them. Just these have front chamfers. Why is this such a weird part? All right, let's do it, just to say we did. Looks like this is going from the inside radius, too. So 1.5 millimeters in from the edges. So can I highlight the paths here? Oh, can I do this? No. There. You're not going to let me select that path, huh? Yeah, it's like I need to add line segments to it in order to get those paths. So we'll add line segments and make this an even more complicated drawing. What, can I not select that one with it too? .5. That actually collides with, oh, because I need to add, oh, yeah, okay, so I need partial from here to here. There we go. This, you, no, what the heck? Huh, it's not, okay, so it doesn't split. Arc, I guess. 1, 2, 3. There. So now that'll probably be totally what the? Yeah, it's going to be tough to actually select this whole thing. That's what I just did. I know what I'm doing. I know that. I know that I can do that. You, 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 not you. You, not you. Get your mouse in just the right location. And then give me that radius. There we go. No! What? Ah! What the heck? I forgot to select that. Ah! All that time clicking. That's the wrong one. Can I just do that and then do? No. It doesn't let me do the enclosed area. What? Ah, nope, that's wrong. Where did my line go? There is a line in there. That would be, why does it select the middle? No, that selected the outside. Oh, it selected both of them at once. No, it didn't. The middle is selected, isn't it? No, that's not blue. What the heck? I guess it chained those together for some reason. Stop it. Don't select the... I think maybe there's just so much going on that it doesn't know what to display. There's that one. Stop it. Oh my God, this is annoying. Yeah, it's very frustrating. There. Did it deselect? It should still be selected. If I do that. It deselected. I'm not doing this. This is so annoying. And I gotta split the other one up too? How the hell did they do this? Maybe they just wanted to torture themselves. Or maybe if I do the extrusions and then do that as like a decorative thing at the end. I guess that's probably, a second sketch is probably in order for that. Because there's too much going on in this sketch. So this is, look at our motor mount, it's beautiful. So let's extrude this to its full width, which is 3.5 millimeters. So I'm going to take all my solids here and here and here, and there's one here, and there's one here, I guess, and there's one here, and I'm going to go in the other direction, negative. Wait, which direction should I go in? I've been modeling it like it's facing this way, so I guess I'm going to go negative 3.5. Negative 3.5, and then I can cut this and this 1.5, wait, 3.5, 1.5, 2, yeah, 1.5 in the other direction. There's that cut. Then the bearing, I can just measure the bearing's width because it's actually pretty accurate to the bearing. Actually, no, I'm going to measure it independently because I think the bearing might stick out just a tiny bit. 2. Okay, let's do this thing there. Negative 2. Okay, so that's that. But I also want to extrude this out to its final width, and that'll probably will need another sketch on the side in order to get there, but we'll just do the initial extrusion. 17.5. and that's a join. Boom. All right, so that's starting to look like our motor mount. We are, of course, going to need a sketch down here in order to do that thing, and then we need to do the hook. Oh, Jesus Christ, Speedy. This is a terrible joke. All right. So is that sidewall larger? No, it looks like it has a little radius around it of like 0.5 millimeter. So I need to give a 0.5 millimeter radius around this slot in order to clearance stuff. So we might need to go back on some steps there. I'll take this, I'll double click on the outside, and then I'll do a radius, and I'm going to make it 0.5 millimeter. Finish that, and then I'll take this cut and I will add my sketch to it. Boop, boop. There we go. All this gets chamfers eventually, which is where it'll start really resembling the motor mount. Boop. But that's pretty good so far. So fart. Yeah, it's going to get a lot of chamfering. A lot. So far, so good. What time are we? I still got a little bit of work to do. That's going to be kind of a creative venture. So we need to model this into the side. When do I do that, though? When do I do that? Because all that, this part and like this and this are probably in the next steps. If I do try to do the cosmetic thing, I don't know how I can. I'd have to do a radius off of this to make that, and then this would be a certain distance here. That changes down there. I don't want to do that. It's sounding like work. What just dropped on the ground? Something just dropped on the ground, and it's somewhere directly beneath me. My hand picked it up just by pressing against it. And if it's a part that has legs, or a part that is rare, like the bearing, oh my God, it's right here. No, it's not. That was a reflection. Uh-oh. Uh-oh. What is the part? Where did it go? What does it do? This is where I have all the integrity in the world of, oh, it is the bearing. There it is. This is why we keep a bright flashlight in your pocket. Put that out of the way. I don't want to lose that. I think I do have more of those. I don't know where they are. What if I make the RC car take the bar exam? What would that be? Okay, so tomorrow is another YouTube day. I'm doing nothing but uploading. So we're going to create a, well, actually, new sketch, and we'll put it on this face right here. So that new sketch, hello. Okay, so we need like a hook cutout on this thing. So that is the very end of that piece. I have what looks like a 45-degree angle cutout that goes, what distance? Looks like it's down a little bit from the other piece. We're trying to make the, oh wait, we could just show it. This is the motor mount for the RC car project. It's a part that I've needed to make for a while. We're not giving it a lot of the decorative stuff that it has. They're the little inset pieces. We're not modeling that. So, all right, so what are we doing here? I have a piece that's going to be a particular height, and it's going to be coming in from a particular distance. So I guess I can measure out to here and then measure the width of it, and then it goes to the end here. So if I take this measurement, I gotta get that right though. I gotta get the right measurement. That's tough to do. $11. Oh, nice even number. So 11, and then it's not. We're not doing a teapot race, although I love the teapot racing. Teapot racing is so awesome. Wait a sec. This is doing some more cursed stuff. this actually comes up a distance. What, Hidonica, was it you? I think it was you that told me to look that up. Okay, 1.5 millimeters up for the bottom. Let's do that quickly. And let's get the microscope thing out of here. Yeah, that was the cutest thing ever. Finish that sketch. We're going back to this one. So we go back to this sketch, and then I'm going to do a 1.5 millimeter box, basically. 1.5. Is that locked down? Nope. Fusion does this thing where it loves to not actually lock things together. You have to go back into the step and lock it down again. And I have a feeling this one isn't locked in either. No, I think that one managed to actually lock itself in. Okay. Yeah, it's unfortunate that it does that, because it's like, I definitely did it. It's an almost unknown sport. It was like a 1995 webpage, but it was awesome. So we're going from object to object. So from object here, and I guess we'll just do that and just cut off all that. So there, that's actually how this thing is designed. It's got this little like overhanging thing to try to organize your wires. So now it's 11 millimeters from this spot here. So let's go back into that second sketch. Into the second sketch. And now I basically, oh yeah, because our sketch exists before the line was drawn. So I'm actually just going to put in that 1.5, that'll mess stuff up if I want to change that dimension in the future. We should not have done it that way. Actually, I mean, like, this is the latest thing that I extruded, so here, let's finish that sketch. Oh wait, I'm going to redo whatever I did to get out of that, and then I'm just going to get rid of this extrusion. Which one is it? Yeah, it's that one. Okay. Yeah. So what was the distance on that? 17.5 from the outside. Okay. And so I'll just delete it. We'll do it again. Actually, I don't need to... Oh, yeah, I do need to do it again. Because that... Well, no. Wait a minute. If I go back into the step, the 1.5 should be there. Yeah, so I can just unhighlight that. There we go. Okay, we're getting there. I'm getting smarter. Slowly. All right, back into sketch 2. We now have that cutout there. So now we can go 11.5 this way. Or sorry, it was 11, wasn't it? It was 11. And that's going to be the start point for the... do it on the original, and then you can project it on the later sketch, right? Yeah. That's essentially what we did, is we went back into that step, and we, even though we edited the original sketch, the sketch is the first thing on the timeline. So if we edit it there, it's going to exist for all the subsequent steps. So we were able to go into the extrusion step, which was the thing I wanted to correct, and we were able to unclick that new geometry that we highlighted. Sometimes Fusion will get that stuff confused if you've got a very complicated set of overlapping drawing areas, and you move something and it creates new spaces. It seems like the program associates some kind of like an ID with a space, and so if you make new spaces, they get new IDs, and there's a little bit of interpolation there that goes on, or extrapolation sometimes. But sometimes that'll get wrong, and then you'll have weird geometries that have been extruded that you have to go subsequently into each step following and correct. 3D printer, wait, I've started 3D printing and working in Fusion now. 3D printer actually started printing well on day 2. That is excellent. That's a great place to be. I love that I can just spool up Fusion 360, and because I know my printer and I know Fusion well enough, I can do stuff like this and say, well, how would that 3D print? How will I put this together? Now, what we're doing right now is we're reverse engineering somebody else's design. So they did this with the intent of having it made in a plastic mold, so it's got different design considerations overall. When we 3D print, it's kind of a little bit of a different animal. So I'm getting like 6.5 on the width of this thing. Let's double check that number. Yeah, 6.5 I think is a safe enough number. You guys can't see that. 6.5. Well, actually, it would be from the 11. So there's probably already have the dimension. from here to here. Okay, that's not the number that I got. Why is that not the number that I got? What is wrong with me? I heard your voice in my head saying, remember that nothing will work for a few months during the first day while I was cursing. Excellent. I'm glad I was there in spirit. That's 17. And we extruded this. I wish it would tell me. I think I just measure it. From here to here is 17. 17 and a half. So where was my 11 measurement? My 11 measurement was first from... Yeah, 11 was supposed to be from the leading edge of that thing. And this is definitely 17 and a half. Why are all my numbers cursed? What's going on here? Okay, I'm definitely measuring 11 to the beginning of this thing, and then 17 and a half for the overall. Why am I getting 6 for the width of it? I'm getting 6. What the hell? What is that? Wait a minute. Oh, wait, my 11 is from the wrong... Okay, yeah, I solved it. I figured it out. Yeah, it shouldn't be. 11 is from all the way to the other side. So this actually would be... it's a half, isn't it? Is it 3 or is it 3.5? What did I do the width as? It's actually... It's closer to 4. Nah, 3.5. So I did 3.5 there. So I need to do the half if I wanted to do that measurement. Let's just take this down. And we'll go 6 in from here. Actually, I just do box, and then that's 6 by, what's the other one? .4. I'm going to say 13 and a half. Why is everything a half? 13.5. Let's just make that into solids. So 13 and a half by 6. Then I have a cutoff down here of 3 by, I think that's 1. I'm going to just say it's 1. No, it's 3 by 2. So I need to go, which one was 3? 3 was vertical. Three, and then another box here. That is 2. Lock that in right there. Looks like it locked. Yeah, it did. Okay. So 3 by 2 on that cut. And then this is such a weird design. It's like they took a radius on this thing. Like, where's my point? Point is 2.75 by 2.4. So I take that as 2.5, and this one as not quite, it's a little wider than 2.5. It's like 2.5, 2.5. Let's try 2.5, 2.5, and just see what that's like. I believe it was, yes. I don't know where the WL Toys original design was, but it's also been copied and recopied. So you can buy parts that are just every kind of part, you know, like including a fully metal version of this thing. 2.2 by 4.8. How accurately do I do that? I could get 5 if I kind of push the calipers out a little bit. And 2.5 by 5. So let's make that. I know I'm just rattling off numbers, but that's kind of what we're doing today. So 5 and then 2.5. And then the center of that hosts its own little opening. It's kind of closer to 1 millimeter. Yeah, 1.2 or 1.5. I don't know which one. I need like maybe a center square, or I just put 0.75 in either direction. .75, and then the other direction 0.75. Kind of clumsy way to do it. Wait, that's not the center. Center's like here. It's going to be really annoying with this piece right there. That's the center. Jeez. 0.75. Yeah, this is going to be totally cursed if I have to modify stuff. And then 0.75. All this just so I have an accurate model of the RC car. All because I wouldn't be able to sleep at night if this didn't look accurate to what was actually there. I need to have it look pretty. That's the whole purpose of this. Ah! There's a desk that when the temperature swings enough. Why are you not allowing me? Please. Oh my God. There's like a desk panel here that when it gets cold enough, it pops and it scares the crap out of me. Yeah, it like wouldn't let me do the perpendicular command. Like this one has it. Weird. Okay, so that will give us the thing. There's also a cut here, but I think I'll use fillet in order to do that. Because I don't trust my measuring. We'll just do it by eyeball. It pretty much comes up to almost like here, but we'll finish that sketch. Then I'll extrude. Okay, I have some giant bolts and washers that are in the way. Those are from the safe. Extrude this. Actually, first, let's do this to object here. And then I'll just cut out the stuff that's not supposed to be there. Why does that look weird? Oh, because there's a little tiny gap, I see. Yoink. Looks like a crab flexing. That's a strong crab. I think that's pretty good. All right, let me take the big cut out of this thing. It's like every outer edge needs to be softened. There's no sharp edges on this part at all. I wonder if that was to help it fall out of the mold properly. We'll take that at 5. How's that look? Or maybe? And that looks pretty good. That looks like the right thing. It's a little hard to see. God, every single dimension needs to be softened up. That's so weird. Okay, so far so good. Now we need to do the posts. So I'm going to go from here, create a sketch, and I need a center line. So we'll get a center line for everybody. And now we need distances to holes. So first off, where did the motor mount go? If I lose the part in the middle of making the part, what does that say about me? There it is. It's hiding behind the RC car. Oh, in the microscope. You guys could see it the whole time. Now I could get the distances for these things off of the main drawing. I could actually measure the distance between stuff and get that accurately. That's gonna bug me. The rounded edge over there. Yeah, let's look at the other drawing and get those dimensions, because we can just get the numbers from somewhere else. There's a sketch in here, deep, deep, deep. Motor front plate rise. That's coming from here. There's so many parts in the way that I can't really see what's going on. Oh, I think I projected them from the other drawing directly into this. Because I think those are outer measurements and not the inner things here. Where's this one indexed from? Yeah, it's like indexing from another hole. That's a weird one. That's a weird one. Okay, so I cannot trust that. Can't trust that. I got to go from, I mean, I can do hole-to-hole distances. That's easy enough to do. Just go from here to here, and that'll give me, well, there's the pin. So I can go from the pin to there easily, but I need to figure out where the pin is. So let's figure this out. The pin is of width 2. It's hard to get a measurement on the edge here. I guess that's all right. Just like that. 3. 2 and 3. So it's actually 4 millimeters from the bottom. Seems like a big distance. It's 2 millimeter diameter, 3 millimeter distance, 4 millimeters to the hole, to the pin. 4 to there, and then we have a pin that is 2. And on the other side, we have a post, screw post, that is 3. Wait a minute, 3.5. I'm getting 3.2. Let's just see what the other one says it is. Because I did successfully print this part. This part fit into the main frame, so I should probably follow whatever dimensions I've got out here. 3.5. Okay, so I was right. So let's do a 3.5. And then 3.5 is with a screw hole of 1.8. That's a weird number because it needs to grip a screw. We don't need it to grip a screw, but I'll just do a 1.8 on this anyway. That's going to be a tough extrusion because there's so much going on there. Okay, so that's our pin and the top piece. The next part is one of the screw holes in the body. So I'm going to go down here, and I'm going to go from the pin to the screw hole. And all I need is that distance. So 5.5. Linear, this thing, 5.5. That doesn't make any goddamn sense. Wait a minute, 5.5, no, 5.5. There we go, that's a little better. And then, were we gonna do 1.8? I guess we are gonna do 1.8. The same screws, so 1.8. And then the distance from screw hole to screw hole going to be from here to here. 17.5. In a construction line. 17.5. God, it's still raining out there, isn't it? That seems like it's a little close to the edge. .8. Not 18. My dot key is not working. Probably punched it too much. There it goes. Let's just double check that with the model to see if it looks like that hole is, yeah, that hole is really buried. That's really far up there. Okay, so that's pretty good. Finish that, and then we extrude this from, oh wait, that all the way, except we need the, oh my God, it's not letting me zoom in quickly. What are you doing? That one. And then we take it from, come on. So from object here of a distance that is equal to, actually the same height as that. No, it's a little taller than that curve. 1.5. Negative 1.5. It's fine. I'm not gonna plunge into that. And then I'm extruding this one and this one. Wait. Yeah. Yeah. The distance below, it's probably gonna be 1.5. Let's double check though. Why did that scroll up? Yeah, it's 1.5. So that one goes 1.5. And then these two are just holes. I'll just do those to an extent. It doesn't come out the top, so I won't go too far with it. And I don't want to go too far as to interfere with anything on the body. I guess we can take this one in a little bit more, just to make it look more like a proper screw hole. There we go. All right, now it's looking like the real thing. Except without those weird cutouts. I don't know how I can model those cutouts. I probably can manage it. It's just work that I don't have to really do. So it's too sharp. This is a very softened part. So I guess the next step is going to be to fillet everything to within an inch of its life, which is really annoying, but it's what has happened on this part. Oh, that's interesting. There's like an arc cutout. Wait a minute, before I even do this. We have a shocking, this is the metal upgraded part. Shorty bought the version of the WL Toys kit that had the non-plastic differential housings, metal. Look at this shocking reveal. There's this weird arc cutout coming from right here. Very strange. So I need to, I'm not going to model these stupid little cut-ins that it has everywhere. But what I will do is get that. The reason that that's there is because the battery holder encroaches on this thing's space. It gets very, very close to it. So I guess what I can do is just, well, I mean, I could chamfer the entire edge until it's way too smooth, or I could do an arc cutout. Chamfer and then bevel. But I think what it looks like is just an overall chamfer. I think what they did is just do, I don't think they were using Fusion 360, although maybe they could have been. Because it just looks like that. Actually, that does not look what it looks like. That's not what it looks like, huh? What do you look like? Chamfer and then smooth with a fillet. Yeah, that is kind of what it looks like, huh? Although this one is sharper just because the seam is right there. Yeah, I think you're right. I think it is it's filleted and then chamfered, or chamfered and filleted. I keep mixing them up. So we'll take a chamfer and then we will fillet the chamfers like that. And then we'll do this and this. Too much. Not quite. I think it needs to be a little smoother than that. Yeah, like that. 1 millimeter. That I think is close. It doesn't quite. I don't know. What does it quite look like? Kind of look like it. Well, I'd have to smooth that too, but to get it to look just like it. I guess so. I guess so. It's just that this corner, I think I need to smooth it first and then go in and do. Yeah, I need to do it in the other order. Well, I guess I could do that. I could just, oh, okay. Okay, that was the wrong view. Because right now, if I try to chamfer, that's not going to come out properly. So what I can do, I can rewind to here, and then I can smooth this and this. Got to do it in the right order. Why does it suddenly give me all this granularity? It's so strange. Wait, that doesn't work. I'm going to have to do an arc cutout. Because now these steps won't apply properly. Yeah, see, it like wraps it around and does weird stuff. So that needs to be cut from here. So I guess I'm going to go into the sketch. So we'll delete everything after the history marker, and we'll take that sketch that exists here, and then find it. There it is. And that's here that we have that arc cut out, right? No, it's over here. What direction is it? It's on the left-hand side of this. I mean, I could use the chamfer tool within this, but it's going to ruin a lot of the dimensions when it goes away. So it's better that I would put an arc in there. I don't know where I would, or no, it would be a sideways cut, and I think we said it was 3 by 3. So I'm going to need a construction box, and I'll need to take this and give it dimensions. So 3 by 3. No, 3 by 3 was way too big. 2 by 2. That's still pretty sharp. It does look a little close to it. Hold on, let's pull the microscope back in and see what 2 by 2 looks like. Because we can then go in and smooth that out. But then, yeah, I'll have to make the cut after. It's this whole order of operations thing in order to get this weird shape. How close does it get to that? It gets really close to that. But not quite there. It looks like the smoothing of it kind of gets there. Okay. I need to file all the burrs off of this part. So, okay, this will work. This will work. So I'm going to make that solid, finish the sketch, then I'm going to take that sketch and extrude. Oh, I didn't. Oh, no, there we go. I don't know. I think it has to be in this order. Wait, did I do that on the wrong side? Yeah, I did it on the wrong side. Back to the sketch. Rewind time. How dare you? So we'll do 2 by 2 as a construction, just like that. Take a normal line and go sideways, corner to corner. There you go. Finish. Extrude here. Yerp. Now everything here has been smoothed. It'd be nice if I could just highlight the whole thing and be like, use AI to smooth it or something. Nope. That's not quite right, is it? Maybe I should keep it sharp. Maybe this part should be kept sharp. Because this whole thing is like really smoothed out when it gets to the real thing. I don't know how to soften everything up. You can see this whole part has been smoothed in every facet. Well, some of them haven't. This isn't smooth. There's this. It seems like everywhere it would be entering and exiting the mold has been super duper smoothed out. What's going on there? It's just like an overhang from the when the part was created. These are all hard-edged except for this thing. And I guess these aren't... Well, those are slightly smooth. I guess I can get away with not smoothing that. It would just be all of these front faces need a little something. The motor thing doesn't get it. It's all the extra stuff. All right, well, anything on the outside facing of the part has a little something going on. Okay, so let's get the corners. Like this here. Bring that out. I hate that this thing isn't... I don't know if it's some setting changed or something, because it doesn't do even numbers anymore. It does a very smooth roll through all the numbers. I gotta like shake the part off. This would be like all of the outside dimensions, but then, yeah, those get smooth. So let's do any of the corners that need smoothing first. This one and this one. Bring that to 2. This one comes out. What does that look like? How does that look like? How does that look? What does that look like? Everybody gets that wrong on the internet these days. It looks like that goes all the way to that end, which I think is like, yeah, it's something like 1.5. I'll have to play with tangent chain when I get a chance to see if that's actually not what that looks like. It's actually more of an arc than that. More of an arc. Maybe like a 2. Yeah, it's more of a 2. That looks a little bit better. Some kind of a lobster claw flexing. What about this front edge? Front edge gets a big chamfer. That one's a big boy. So I'm going to take this, give it a big boy chamfer of 2. Yes, good. Okay, and then we can take, I mean, I guess I'm going to have to do like the tangent chain all around this face. Can I do that? I guess I can. That's pretty handy. What happened here? I guess it needs to have connection or something. Well, let's do that. And that was, let's take that, 0.5 might make it not like me anymore. No. I guess that works. So that, what's going on here? Highlight the face, this, 0.5. Yeah, that works nicely. And I guess it chamfered the whole thing for me, which is actually fine. Although it looks like it's a little bit much up here, but I guess that works okay. Yeah, and all the inner mold facing parts are all sharp edges. I could put like a 0.2 on it to make it look a little bit more like the right thing, but I think I can just leave the part like this. Let's do this one too, and do that in just like a 0.2 or something. Yeah, you can't be 0.5. Let's do a 2.5 on you. There we go. That looks a little softer. Oh yeah, the pin too. So hit this one. Just a 0.25. 6. No, just 2.5. Get that sketch out of there. That's looking like a motor mount, if I ever done saw one. And I believe I do. I done saw it. It's funny, I don't have anything to index on in the center of this, which is unfortunate. Oh, I guess I want to drop just a little softness on this. Let's do a 0.5. 0.5. And then I don't know about not changing the tangents. It seems like if I hit this, it might be really awkward. Don't do a tangent chain. It seems to still be tangency weight is 1. Yeah, it's still going to mess it up. So maybe we just leave that alone. Whew, that was a lot of modeling. Let's make this look like black plastic. So appearance menu. What does the back of this thing look like? Oh, it's flat. Yeah, it is flat. Huh. Neat. I mean, there's a little bit of softness to like the bearing exit. Maybe not. No, not much. It's not much. Plastic. Now, is there a matte? Will be opaque. Oh, okay. So you need to unselect the stuff. Well, I don't think it's going to work out on that. I don't think it will. Plastic, matte, black. It is a little glossy. No, it actually is pretty matte. It's pretty matte. Let's just do matte black on the whole thing. Bonk. There we go. We'll never be able to see any of the contours of this part ever again because it's like invisible now. That probably shouldn't have had such a chamfer on it. That's okay though. Okay, so that's our motor mount. I mean, I think that's pretty accurate to what we've got. Oh, I didn't hit that top edge, did I? Does that have a hard elbow on it? No, it does not. It very much does not. So I need to go all the way back to where I was doing that. So that's somewhere around, it would be before I did, yeah, let's go here. And then I'm going to hit this top edge with a 2. And then we can roll the history marker back. There we go. Okay, now we have the part. Whew. That was a tough thing. A very strange shape with a lot of weird contours on it. Now we have a motor mount. So I can take that and pull that into here. And I just saved it. So actually, let me close it too. And I'll pull that into my main drawing. We'll have to see how it fits later. Right now, it's just kind of going into the drawing of everything else. When we work on this next, we'll do all the assembly, I suppose. What direction is that face? That faces this way. So we'll put that in there, and that's going to prime that for the rest of our stuff. And I guess I just need the motor now. Just the motor and that servo mount I'm going to have to figure out. So where is my motor? It's in motors. Bring that in. And then get that into place. It's like we're laying out all the parts that we're going to build an RC car out of later. What is that called again? The staging where you put everything out? There's like a Japanese name for it, I think. All right, and then we need from the other thing, we need to do this. We need to make a part. It's not just exploded view. There's a name for where you lay everything out on the table. It has become a puzzle. It's not quite. I know where everything goes. I know all the answers. So what I need to do is I need to take the part and I need to make it into, so let's go to WL Toys and then let's go to this part right here. Oh my God, where is it? It's in bodies. Bodies, servo, plate, and then I need to save that. See, the thing is, the plate that I've got in this one is a much earlier version. I guess it still has the same stuff in it, so I guess we'll do that. Put it all on the table. Yes, it's the Japanese word for put it all on the table. Okay, so I need to make this into a part. Create component from body. And I go down to the component, all the way down, save, copy as, save as mesh, rigid group, configure component. I mean, I can export it save a copy as is that servo plate into there. I don't know if it'll be an editable copy. Or if this will be a giant file that has like a billion things in it. Oh no, it just doesn't have any history or anything. There's one singular base feature. Okay, well that's fine. That works out. This was made specifically to 3D print. The unfortunate thing is that I want to move the servo back just like a little tiny bit, and I can't do that here. I can't actually do that. I want to move that servo just like a tiny, tiny bit backwards. And the question, it's going to break everything, right? It'll absolutely eliminate most of the stuff that I've worked towards. So maybe I can do that here. I mean, or I could just redesign the part. I could just I put a lot into the design of this part, though. I kind of want to keep it around. I liked this part. This part was friend. Because I can use this to create the electronics holder, and then I can bring that into the next, you know, part of this whole thing. It's just, I don't have the steps that made this don't exist here. They exist in this. So if I were to move that servo, if we go all the way back to the first link step, which is this, I believe, and I move this back just a tiny little bit. I measured that. This could break everything. Negative 0.5. And then I finished the position. Ooh, it broke a lot of stuff. It broke a lot of stuff. There were no survivors. I think it actually did okay. It doesn't understand one extrusion. Let's check it. Was that the same as this extrusion? Yeah, extrusion 29. I thought it said 89. Are there errors in any of these other pieces? This is what I mean about this drawing being completely cursed. There's too much going on. I used it to design too many files. Where are you supposed to be? Oh, you're over here. You don't matter at all. No target body found to cut or intersect. Huh? What does that mean? All right, whatever. Whatever. So did that moved it back. Hold on, let me get just like a measurement and see if that actually did anything. So this distance is 3.864. What a nice round number. 3.864. This one should be more than that. It is not. I don't think that movement step actually did anything. I wonder if it's being overridden with another one. No, it doesn't look like it. So that didn't actually change anything. I could make my own part. I really don't want to do that. There was a lot of weird stuff about this part. This part has some weird stuff going on. Although it really isn't that weird, to be honest. I could make this part again. All I need is just a projection of where those 3 posts are. I could use this file to do it. I could make a sketch on the base, take in the 3 posts, and then start from there. I would have to take the servo in too in order to do all those. And then I had to click about 500 different geometries in order to make that cut out. Okay. All right, well, we're going to end there. There's stuff that I can do on my own if I have time. Tomorrow is a complete upload day. Tomorrow I'm just uploading. That's all I'm doing all day. I will be on Discord if you guys feel like bothering me, but we're just going to be uploading video. I'm just going to be putting things into YouTube, all of my e-waste, so that if anybody wants to reference something that I said a million years ago, maybe just cancel my whole career, go ahead and find it in those streams. Other than that, I will be around. I will not be trying to get the top speed anymore because it's wet out. It's going to be wet out for a little while. If it dries up, I kind of want to finish this electronics mount because every single crash, this thing is flipping around and it's going to catch on something, and that'll totally ruin my beautiful wiring. So I kind of want to put it like in a thing that's going to contain the wiring. We had a lot of subs. We had a couple subs. We had a lot of follows and stuff. So thank you very much, everybody. I will be back on Thursday, and we'll do something else. We'll be working on something. If it is the RC car, then so be it. But I kind of want to keep the variety going here and work on something else. The 3D printer, I put that circuit board back in so that I could 3D print stuff. But we still need to wire it into the control panel, and then I can use that three-phase fan in order to, you know, cool my prints. We still need to make something like a blower on the end, and I think I can find a model for one, but I don't think it matches up with the Hymeria hot end. So we got all kinds of work to do in all kinds of different sectors. I'll catch you guys on Thursday. Until then, where am I typing this thing? Here's the end card with all of my information. END. Bonk. There we go. There's all of the information for you to write down somewhere. And I'm going to go take a rainy walk with my puppy dog, and I will catch you guys later. Have a good one. I got to stop YouTube too.